Yeah, exactly. So this is a really important sort of model for how we got digital communication at all. But I'm not sure it's going to help us a lot with communication between people. You know, maybe you can be inspired by it, something like that. Yeah, so there's 3 ways to, and you can say, was my message successful? Well, you can say that 3 ways to say successful. The technical version is, did it get through? Yes, he got the words. But maybe my words were vague, and it's like, meet me at 3, and he thought I meant today, but it's really tomorrow. So that's the, semantic part. Did my message convey the right meaning? Maybe it did or did not. And then the effectiveness, did it have the right impact or effect? So when you're looking at effectiveness of communication, you can measure different things. So the problem with this, though, I just talked about with the people, is it's about messages. So there's nothing about people and their goals and their, whether they're stressed or they're pressured. Yeah, that sort of thing. So we need another model. So I would say this model is not enough, right? You hear the model and you're like, okay, nice model, but it doesn't help me out. So now we have structural communication and linguistics. The linguistics world analyzed conversations between people and realized that there's this thing called turn taking, and they started analyzing structures of speech. Like, you can have conversation with some people and they'll say, so do you think we should move the flowers over here? Or somebody said, we should move the flowers over here, right? And you can look at structures like that. And that's sometimes helpful, but it's not as good if I analyze all the parts of speech and the grammar. That doesn't really help me with why 2 people failed at good communication. So I'm going to, we can be informed by that model, but it's not going to help us out. Distributed cognition was inspired by this guy Hutchins, who rode on a US Navy ship. Okay, and he's at the front of the ship on the bridge where they're steering the ship. And what he noticed is that there were about 7 people on the bridge, and each of them had different roles that were tightly integrated so that you couldn't really say that one person was steering the ship. It was like the team of 7. And they had communication between each other. And so he was arguing that the team of 7 has cognition like a unit of a group of people, like a single human has cognition. He said this group has cognition. And that was the distributed cognition idea. And I would say this is not a hot topic yet, but I think it will come back as we start doing more AI-human integration. And maybe people will talk about cognition of the duo. Like, I'm working closely with my AI agent. And how effective am I at my distributed cognition between me and the agent? Okay, common ground is one of the most helpful ones. Common ground is often what you do when you first meet somebody. You're like, oh, I'm from Orissa. Are you from Orissa? And you establish. I think people are sort of wired to, like, they come in and they meet somebody and they're like, oh, do you like, this food? I like this food. And they establish some common ground. And that means that, it's too hard to meet you and say, I need to know everything your brain knows, and I need to send you everything my brain knows so you'll know, are we compatible? Are we like this? Or this, or this, or where are we in relation to each other? And that's too hard. And so instead we do these common ground moves, right? And you'll often, I don't know, is it popular here to talk about the weather? Not so much. Okay. So in the Midwest where I come from, almost every conversation starts with the weather. Like, oh, it's unusually hot today, or it's not as hot as normal today, or it's windy today. And it's sort of useless, but it's establishing common ground, right? Is there a topic that everybody starts with here? Like when you first... Very humid. So you might say it's humid. Okay, yeah. But if you're going to start, if you meet a stranger and you're supposed to, talk with them a little bit, is there a first topic you're going to hit? Food. Okay, yeah. Well, how do you like your bread or something like this, right? So food would be a common ground topic. And when here's the things you learn about with the common ground. Like, what if I say, do you like puri for breakfast, right? And they're going to like, oh yeah, I like puri. So if they don't respond the way you expect, then you're like, I need to go deeper. I'm a little like, meh. And so you can calibrate with the other person. And you can also calibrate, like, what if they take too long to respond? You're like, oh, maybe they have learning disabilities and I need to talk more slowly. So there's all this calibration that you're doing with another person in just 30 seconds or 60 seconds, right?
So common ground can be different for generation. If we had a generation gap, the common ground may be affect the conversation.
That's right. Yeah, he's asking about different generations where they share these common grounds. So you might have to work harder to find the common ground, right? You might have to say, I mean, maybe the food would work, right? Because the food has lasted, perhaps. But if it's about Instagram, there's probably not something, I don't know, right?
Elder people are more engaged in sports stuff.
Okay, that's great. If they know their sports, you can say, what did you see this last match, right? And this is a good technique. If you're an engineer and socializing doesn't come naturally, which is true for some engineers, then you can use this as a technique. You're like, okay, I'm going to find the common ground quickly, and you have your topics you're going to roll out, and then people will talk to you. Yeah. So, and it can be nonverbal as well, right? It can be gestures and all sorts of things. Oh yeah, and I talked about the calibration. So you're building a mental model of your partner. I'm talking to this person. Like, how are they doing? Oh, and I should also say that this happens in job interviews too, right? So there'll be these Zoom job interviews. And I have former students who are now working at the big companies like Google and Meta, and they'll say, oh yeah, we have these Zoom interviews, and they'll say, oh, the interviews are often like 10 or 15 minutes, but within 2 or 3 minutes if like you want to deal with this person, right? And so they're making those judgments. I'm not going to argue that's fair, right? It's not necessarily fair because they're stereotyping. They might be judging based on how attractive they are or whether they share attributes, but they are making those conclusions. Like our brain is processing that very fast because it's a survival instinct a little bit. Like if you're talking to a stranger, you might there's a very small possibility this person could bring out a knife and chase me with a weapon, right? So are they going to do this? Okay. Oh yeah, so these are other methods for grounding besides topics. So the cognitive artifacts are things like notes or diagrams. So are we doing okay? Yeah. If I'm decide to build a new house and I hire an architect and a construction engineer, those people speak very different languages, right? But the blueprint of the house can serve as common ground. So we can all look at the blueprint and share in this artifact. I may not understand the architect and the engineer, but I can say, I want my kitchen to be like this. And they say, oh. The Zoom, it's interesting that you can think of the different affordances or features of these communication modes. So WhatsApp and messaging like that doesn't allow you as much about emotion. And so then we have all these emojis that are like supposed to help with that. Zoom, you get to see people's face more. So they have different affordances. And then the social norms too. Like I just said, in the Midwest, we're always talking about weather. So if you came, but we talk about food too. So if you came to the Midwest in the US and you're like talking about food, the people would be like, oh great, I understand this person. But maybe I come here, I talk about the weather, and you're like, why is he talking about the weather? Right, so there's might be norms. There's some people in this article that this is all based on who have gone into more detail on what does it mean for affordances to be good affordances. Affordances are something like a teapot has a handle, which is an affordance for picking up and pouring, right? So good design things have affordances. This has a nice affordance for pulling the chair in and out. It's a little handle. And you can review the affordances for building common ground. Are they visible? Are they contemporaneous, like for both of the people in the communication? Can I see them? Can I change them? So there's a big thing about indirect communication. So in different cultures, there's a concept of power distance, which is to what extent is your boss your friend versus somebody you bow down to, right? So when I lived in Namibia, for example, we got to know, in Namibia, wherever you go and you park, there are these parking guys. and the parking guys come out and say, I will protect your car. And then you're expected to pay the parking guys a little bit of money afterwards. And I think really what I've heard is that these are the guys that used to steal things from your car, but now they get more money by saying, I will protect your car. But they don't really do much. But you always do this, and everybody gives them a couple cents. And so when I went back to Namibia a year later, after we lived there, several of the parking guys remembered me, and they're like, oh, Prof. Stephen. And two of them bent down to kiss my shoes. And I was like, whoa. Like, I'm not used to that, right? So that's a big power distance. They're thinking of me as a big power distance. And traditionally, power distance is bigger in Asian countries. I don't know how much it is in India, but especially like Japan, it's like really high, like your boss, is way up here. In Scandinavian countries, Norway, Sweden, it's very low, and you're out playing golf with your boss. But this can be a danger, and then I put an aerospace here in healthcare because there are examples. There's a very sad example. Airplanes have black boxes that record the conversations. And there's a sad example from a Japanese airline where the co-pilot knows that they're doing the wrong thing, like they're flying the wrong direction. But the power distance between him and the pilot is so great that he can't tell him outright. So he's not going to be like, you're flying the wrong way. Like that would be the American version, right? Or the Swedish version. And instead, he's like, don't you think we should check our heading? And the pilot's like, no, we're fine. Don't you think we should check our altitude? This sort of thing. And then they crash. Like the whole plane crashes because he's not communicating. And I'm like, okay, this is awful. And you end up with similar things in healthcare. So there's a power distance between doctors and nurses often. And different countries have it differently, but in a lot of places, the doctors are like, we're up here, and the nurses are like, okay, we are the humble servants. And but nurses are smart enough to notice things going wrong. Oh, the anesthesia is not going right, this sort of thing. And if they don't feel like they can communicate with the doctor, that's not going to work. Right? So part of what you're looking for is this indirect, that's called indirect communication, when it's like, don't you think we should check the altitude? Okay. This is a brief definition of team versus group. So team has a shared, they have an outcome, desired outcome with shared responsibility. A group is more like, oh, we're all going to dinner together. Coordination is a little bit more robust. The coordination is what the team's doing, but the cooperation, collaboration is more just, oh, we're doing things together, but the coordination is like, we are planning carefully. Right? And so in the early lectures, I showed this, right, with the information processing. And so there were some people in the team model who said, hey, let's do that with a bunch of them. And so let's have several of these and have group information processing model. And we're going to go through all the different, how fast does the group process the inputs? How fast does the group do this thing? And that doesn't work so well. It is what you call reductionist, meaning we sort of lose sight of, is there this phrase here about the forest for the trees? Like you don't see the forest because you're looking at the trees. I don't know, maybe that's not a phrase here. All right, but maybe you get it. It's like I'm looking at this one tree and I forget to look at the whole big picture. So this is the problem with this, because I get down to tracking the timing for individual communications, and it's difficult with this model to get out to the big picture of were they successful at communicating. And and so some people call this microcognition because it's like down in the tiny level. So then there became macrocognition. And this fellow Gary Klein is famous for this. And Gary Klein is a big influence in this field of team behaviors and monitoring teams. And in case you're wondering, why does Stephen care about teams so much? Most projects are done by teams, right? And if I'm a manager and I say, which team should I give? Am I give the next project to you or you? Like, ideally, I need some model of like, well, they're a really good team on the last project, and my new project is, is it related enough to their project that they're going to be a good team on that one, or maybe not? I don't know. It's hard to analyze that sort of question. But it's important in workplace. So, here's Gary Klein says, here's what you need. You need shared mental models. We all share the mental model of what we're doing here. Like, what are we doing here now? So when I gave you the speculative fiction assignment, hopefully pretty quickly you could get to the point of like, oh, what are we doing here? We're doing this assignment. We all understand. And the adapting is interesting. So if you're a team and you may realize like, oh, one of us is a better programmer than the other, so maybe you should do the programming part and I'm going to do the writing part, that sort of thing. And that clear communication about roles, the statement I just made about you do this, you do that, that's willingness to communicate. Instead of just one person be like, well, I'm going to do the programming, and they just do it. I've seen teams where one person just starts to do the stuff, teaming behaviors, teaming papers. But you can skip that, and the second half is these behavioral markers we pulled out about, for example, how do you measure trust on a team? Like, do the teammates trust each other? So we would say things like, okay, based on analyzing many, many papers, we see that behavioral markers are things like occurrences of team members seeking out opinions of other team members. So I can say, hey, what do you think of what I just did on the project? That means I trust you. That means I trust that you're not going to be like, you are terrible, and criticize me. So that means we have good rapport. And then some things are reverse coded. So reverse coded, normal coded is if I see more of this, I have more trust. Reverse coded is if I see more of this, I have less trust. So if I'm reminding each other, I'm like, hey, you really got to do that thing, remember that? That if I say that a lot, that you're getting the message like, oh, you don't trust me. You feel like you got to remind me all the time. Who are you? So that's reverse about the more of that you have, the less trust you have. So we were proud in this paper to get a little bit closer to coming up with behaviors that we could count. Like our goal was to what can I actually count on a team? Just like when you're a video game analysis, you're like, what can I count to show expert play, expert strategies? So these are things we feel like we can count. Now, the hard thing is it's not easy to count these necessarily. It's not easy to have an AI count these for us. Right? Sometimes a human is involved. Here's one on collective efficacy. Efficacy is a fancy word for confidence. Self-efficacy is about self-confidence. I could say, what's your self-efficacy with using Google Docs? And you're like, oh, I'm great at Google Docs. Or maybe you're like, oh, I'm medium at Google Docs. And that's your confidence. Collective efficacy is what's your team efficacy. So if I have good collective efficacy, team members are going to acknowledge each other. They're going to request backup when they need it, that sort of thing. They're working well together. They're confident they can work well together. We had cohesion, which is like team spirit. You're going to, if you own up to your mistakes, if you, celebrate achievements, things like that. And it's funny, you might think like, oh, occurrence of phrases like, we make a great team. You might think that's just a throwaway phrase, like we did well together as a team, and you say, oh yeah, we were good today. But that really matters. Like that's going to affect your sense of the team, for the next week or two, at least, right? So some of that really helps. So in the cognitive engineering world, here are a bunch of big challenges, right? And I should have updated this slide to be like, we've got human-robot teams, but we need human-AI teams as well. We want distributed teams, like on Zoom, right? So many of the workplaces now still have the workers all distributed at home, working from home. What sort of technology? If you three are working together, but you're at different faraway places, what sort of technology can we give you that gives you a sense of how's the project going? Are we behind or are we ahead? Are we successful? And there are these websites like Jira, and there's a variety of people trying to do this. I haven't seen it feel great yet. I've seen people do it decently, but okay. So now let's talk about trust. Yes? Sorry?
In this paper that you were discussing.
Yeah, the Sotomayor paper, yeah.
Who is marking those? Is every team member marking it?
So yeah, his question is who's marking all these things that you're going to measure about like trust or something like that? So we would record sessions from teams and then the researchers would mark it. Right? So the team members themselves, maybe the team members themselves could do something. Maybe some AI technology that's listening to our recordings could do it. but mostly it's been researchers listening to recordings.
In practice, when say a team has 8-9 members,
Yeah.
usually in every team there'll be two people at least would not be actually working, or they're not really as much involved as the others are probably. So how do we know that he's a good team member with him but not with the other? How that whole connection, how is that measured?
Yeah. Like how many, like ideally I would know enough about the team that I could say, oh, if I put these people together, this one's going to not work because he feels dominated by this one or intimidated or something like that. Yeah. So I don't have an easy answer for you, but I feel like these are metrics that could get you closer, right? And you could start looking at, okay, their team did work together and I saw this contribution from him and this contribution from him and this contribution from him, and they were not balanced. Maybe, but on the other team, when it was just them two and him, then it was a different dynamic. You know, and you start modeling the team and then the employees. So ideally, you're going to have, I feel like in the perfect company, you would have this model. You know, I've got 20 software developers, say, and I've got a model of who works well with whom and who pairs well, who works, you know.
Is that qualitative assessment?
Sorry?
Is that qualitative assessment?
It can be,
Or
I mean,
quantitative?
it's a good question. I feel like it's quantitative because I'm counting stuff and I'm pretty objective. So if I am going to count these, I think I could train you to count the same way I count, and then it would be objective.
What parameters we are basically calculating, and how we are calculating those things.
So we're going to, I mean, I would have measures of trust, measures of team cohesion.
A measure of trust. Trust, how we are going to calculate that.
So this would be, for example, on this, I could say there's 8 measures of trust, and I've got,
How many persons in a team are responding that so based on that.
yeah, that's right.
So that is basically the frequency we are going to calculate.
Yeah.
How many are giving the same kind of the answers about the others, like that. And we can record that.
Right. I could do this for different team members. I could do it for the whole team and then count it up and sum it up and say, you know, here's my team score.
It's like a scale and there's a mean of it.
I mean, you could do Likert, but then it's more subjective, right? It's more somebody estimating. I'm talking about you get a recording and you actually count the number of times that information is withheld from somebody or the number of times that they ask for backup. They send backup.
Am I correct? Like number of opportunities we had and how many of them went right?
That's right. Yeah. I mean, so I feel like we move the field forward a little bit with the table like this because these are actually countable, but it's not necessarily clear how to score it and like what equation to use.
Something
Something.
like we ask for like a survey form and ask them.
I mean, I think it'd be more objective if you had a recording of them and you just counted things. I mean, you could do survey things, but then it's self-report.
Something like asking someone in the last 1 week, how many members followed you up in your team?
Yeah. Yeah, I mean, you could do survey each person, how much do you trust the other person? There's other measures. I like to keep it objective if I
These
can, right?
results, so whatever the outcomes we are getting from these results,
Yeah.
okay, analysis. So how we are going to correlate with the cognitive load or cognitive skills.
So I think the outcome of this would tell me, okay, this group of people will make a good team, and this other group of people will make a not as good team. And so when I move forward, I'm going to need to pick this team. And that could be for product design or for analysis or whatever. So I think it's part of the cognitive engineering because you're trying to, your cognitive engineering to me is about fixing
So the teams
teamwork.
who are going to get less score will be having the more cognitive loads.
You could argue that too, and more mistakes. Yeah, they're going to make more mistakes at work.
So there will be more cognitive loads on that. Something like that.
It might be more load. I'm not sure you could link it directly to load, but maybe. I think you're going to link it directly to performance. So the team that's not as good is going to have lower performance.
So because this is going to affect the performance.
Yeah,
So
Yeah.
in that way we can correlate.
that's right. So if I have a doctor and 2 nurses doing surgery, and they really don't trust each other because the doctor was harassing the nurses, like that's going to be a bad surgery. Like it's not going to be a good surgery.
Before this topic, what you discussed, like the communication and the
Yeah.
information.
Yeah.
So what about the information which we are receiving through some messages? Okay, that was something like that. So the amount of information which is contained in a message, right? So based on that, how we can calculate the cognitive loads?
So you could, I mean, you could rate communication by how effective it is on, you know, if I,
Is there any direct relationship? Is there any formula? Is there?
I think,
Parameters you could calculate. You should calculate the cognitive loads.
I don't think directly on the cognitive load, but if I have difficult communication, I'm going to have to spend more time thinking about what you mean. You know, if you tell me something about,
Like common grounds you told, right?
right.
So it's common ground. So based on that, how we will calculate this? There is no direct measure. Is there? Interpretation only.
Well, what I would prefer is that there's an objective way to measure the common ground, right? And we have like concepts and I think we try to encourage that, but it's not always possible. So I think it's like we're trying to take communication, which is really a fuzzy topic, and it's like, oh, that's like psychology. And we're trying to be an engineer and say, if I'm going to be an engineer and I like to count things and measure things, how do I measure communication? How do I measure trust? So it's like I'm taking these fuzzy topics and trying to measure things. I don't know. Does that help? Yeah, yeah. Okay, so a little bit more on trust. Trust can be this psychological thing, like I trust you and I feel, you know, warm feelings about you because I trust you. But it can also be behaviors that result. And can I measure it, right? So on the psychological side, we have papers that talk about, you know, to what extent is one part of the team going to help the other part? Are they going to rely on each other? It's some of these same topics we just talked about. And the thing I really wanted to get to is this idea of these 4 concepts. This is from John Lee. John Lee is this guy from Lee and C, and also Meyer and Lee. John Lee is sort of a famous founder person thinking about trust. And this works really well with AI. So I get humans and AI working together. Lee was originally thinking multiple humans, but if I do humans and AI, we can say, okay, compliance. If the smart tractor says you need to stop and adjust your fan speed, then am I going to obey that? Like, do I trust that tractor enough to say, oh, it told me to adjust my fan, I am going to adjust my fan. Or this is like when your parent says you need to wash your hands more, you might say, I don't care, right? You're going to make a judgment about, you know, whether you're going to be compliant. And then the reliance is, how much am I relying on this? You know, I set the tractor to do auto steer through my farm field, and it's auto steering through my field. Am I going to trust it just to let it go and not worry about it? The spillover is, am I going to act, I internalize the AI system's guidelines enough that I'm going to take action without it prompting me. Here it's prompting me, like, hey, you need to do this thing. And the spillover is like, I've learned, I've been tutored by this agent, like, you know, brought up like a parent would teach a child. So they teach you to brush your teeth maybe, and then later in life you brush your teeth without them telling you. And then reactance is the opposite. Reactance is like, no, I'm not going to do that. You told me to do this thing? Like, but I'm the one who knows me better, right? And you get some people like that. The system, especially in the US military, thinks a lot about this because they'll worry that there's some soldier who's deciding, okay, is this the bad guy or should I send a drone over here? And the system will say, you should do this. And the soldier's like, what? I'm the expert here. Like, don't tell me what to do. Right? So you need to have the system sometimes be more gentle. So we have the Teslas here, right? And I just put examples of this. So examples of the compliance, reliance, spillover, reactance. In this ad, it says self-driving car. Well, there's no true well, I shouldn't say there's no. Well, there's no truly self-driving car yet. But we have these Teslas that'll, do some autopilot. And you look in the fine print, and it's like, technologies do not guarantee that a driver would not suffer injury. So there are these different levels of autonomy of the vehicles. And the Teslas are like, well, I can drive a little bit. And then you get the Waymos, which, I don't know if you've seen the Waymos, which have no human in them. But they're still not truly autonomous because there's a human that can dial in from the headquarters and steer them remotely. So here's a brief ad from this guy who's supposed to be a big, tough sports star, but he's worried about AI. LeBron James. So let's see LeBron James here. Let's see if it will load. Am I loading? Yeah, I'm still on Wi-Fi. Okay.
Some people are fearless. No pressure too great, no stage too big, not afraid of anything.
Yo, bro, your car's here. Nope, it's safe.
It seems like 80 times better than you do.
But I see there's no driver. Get in.
Intel is helping power autonomous cars you can trust, so we can all be fearless.
Hey, yo, I'm keeping this. I'm keeping this.
Okay, so this is an Intel ad, but I've ridden in these twice. I don't know. Are they in India, the driverless cars like this? I don't know if they're here yet. They're in the US, they're only in like 5 cities. And it is a little weird. You're in this car and it's going by itself. But at one point we're in the car and it comes to an intersection, and both roads have like 2 lanes on each direction. So it comes to an intersection and and the stoplight's broken. And there's a police officer in the middle directing traffic. Like, okay, you stop, y'all come on, now you stop, you come on. And he was like, you stop, to the Waymo car, and it stopped. And I was like, huh. And then he's like, okay, come on, and the car just goes. I was like, I don't believe that that's real, like that's humanless, right? So then one of my friends who works in this, he's like, oh no, that's when the human took over your car from headquarters and was like making it go the right way. Because we're not there yet. So that's, it's still interesting. But. So there's some trust if you're going to be trusting these vehicles with your life, or like, would you put your 5-year-old, once we get these vehicles popular, or maybe there's going to be autos that are self-driving, right? And you call up the auto and you're like, take my 5-year-old to grandma's house. Like, are you going to trust it to do that? I don't know. So there's this idea of explainable AI, or XAI. And this came up in the military because if the AI is saying that brown van is the bad guy, you need to shoot the brown van. Currently in the US military, they don't have AI making death decisions, like shoot the thing. They have the AI recommending these things, and then humans have to check it. And so what you want is this explainable AI where you can ask the system, well, why do you think it's the brown van? And it would then tell you, like, okay, I've seen the brown van 4 different places where we've also seen the suspects, and in 2 of those places there was bomb material, and so it gives you the whole justification, and you can be like, okay, I get it, it probably is the brown van. But if it doesn't have a good explanation, which a lot of AI doesn't, a lot of AI is just like, yeah, I've got 80% confidence that's the brown van. Then you're left with like, okay, I'm not gonna base my shooting on that. So everybody wants explainable AI, but it's hard because machine learning and neural network systems they're all just numbers. There's not a lot of explanation inside, right? Okay, so briefly on teaming. Have people heard this phrase, forming, storming, norming, performing? This is the idea that you get together as a team, like I random assigned you all to teams in the activities, and you're forming together, and it's like, oh, hi. My name's Steven, my name's Mohit, whatever, we're a team. And then everything's friendly. And then the storming happens usually a little bit later, like when you're a multi-week project, and you're like, wait a minute, I thought you were gonna do the thing, but you didn't do the thing, and I thought we were meeting at 9, but we're meeting at 10, like you didn't tell me, and people they get cross with each other. The norming is about having norms of behavior. So after you work together enough, you can establish team norms, and then you say, okay, now we know how to work together. We know each other's schedules. We know that we like to communicate on WhatsApp in these ways, and then you can really perform. And I say it's can be hard and okay to talk about. What this means is that if it's a good team, you periodically ask yourselves as teams, how are we doing as a team? And it sounds a little awkward, right? It doesn't sound like normal conversation, but it's really valuable. If you're doing a team project that's like 2 months long, at least once a week, be like, how are we doing as a team? Are we communicating well? And that gives an opening for somebody to say, I wish we knew more about X. I wish you would tell me more ahead of time, or something like that. So here are 3 basic challenges. I talked about the power distance. And so teams that have lower power distance tend to work better together. But you can't fight culture and training too much, right? But you can try to do what you can. So by the people who believe this, for example, at my university, we're taught to learn when the students' birthdays are and to acknowledge them, be like, hey, it's your birthday today, I brought some cake in, or something like that, or a muffin or something. And so that's one way to reduce power distance a little bit. But it depends on where you are. This is the idea that you might not be a good team member if most of your life you've been told, for example, to shut up. Or if you're a part of a big family and you don't have a lot of time, or if this happens a lot in the US where we have these minorities who are darker skinned or people of color, we say, and the teachers are not like, I'm a racist teacher. They don't think they're racist, but they tend to not call on the people with colored skin as much. They just have statistics about like, oh, they don't call on as much. So then that is effectively telling the person, your voice is not so important. And then there's this diversity. I talked about the Big 5 personality scale. If you want to learn about your personality, you can go Google something like Big 5 test, and then you can learn how extroverted you are and that sort of thing. And this is useful. For example, in our department at work, they made all the professors do this test. And then we had to share our results with everybody. And what was interesting there is there's a guy I've been working with, Michael Dornick, I share a lot of interests with him. And he came up extremely introverted. And I tend to come out extremely extroverted. And they were describing what that means. So the introverted people, social interactions are tiring, right? So you go to a party and you have to recover later. And introverted people tend to avoid conflict because it takes a lot of energy. And I'm like, oh, Michael doesn't like conflict. Huh. Which was new to me. I'm more like, if there's a conflict, like, hey, let's talk about it. Let's figure it out together right now. And I realized there I'd had these conversations with Michael where he was feeling really awkward and he tried to shut him down quickly. I'm like, oh. So that's sometimes useful to know that to be a better team. And to think about, you can fix this for humans and you can also fix it for human AI teams. All right, I'm going to skip over that. Okay, here's an activity you can do very briefly. Just on writing or on your phone. There are traits about you and your identity, and you have a choice about some traits and you don't have a choice about other traits. Like I can't change the fact that I'm white and male and tall and that I was born in Texas. But I also chose to be an engineer, I chose to get married, chose to be a dad. I did scouts a lot and camping, and I play the accordion. So I can choose those things. So then write down some things briefly about yourselves. Just spend 5 minutes doing this. Like 2 columns. Things about you that you can't change, things that you can. Let's do this for 5 minutes. And you don't have to share them. You're not going to share this with anybody, so you don't have to feel embarrassed. You can write it on your phone. You can do whatever you want. Just spend a little time thinking about it for a second. So as you're doing this, it's For some people, it's really interesting to do this and reflect a little longer on it. I'm not giving you as much time here, but you can ask them questions about, here are these identity tags. How do they affect the job I'm going to have? Right? How do they affect what sort of interactions I have with other people? How do they affect the career I'm going to study? Right? And so how do they affect things and who you are? It's just worth thinking a little bit about it. And it's both for yourself and it also trains you to think about other people. So you get somebody, like maybe I join your team and you're like, oh, I got this tall white American on my team. What do I need to do about that? Like, do I need to do anything special? Do I need to make sure he has milder Indian food? I don't know. So it makes you think some about accommodating the other team members. And that way of thinking is going to help with the AI team members as well. Like, what does this AI know about me? And what are its tags? Like, does it have tags? Does it have an identity? A lot of the AIs right now are programmed to flatter you. Like ChatGPT will be like, great idea, And yeah. Okay. I'll also just note that it's hard to talk about this stuff sometimes because it's implicitly when you talk about this, it brings up the fact that people aren't as equal as we wish they were. Like I have benefited in my life a lot from parents who really valued education and pushed me through education. And even though I grew up with a single mom and was pretty poor, she valued that hard enough that she married a wealthier guy and then we got, that helped me out. So, but not everybody has those opportunities. So then you're with your peers and you're like, okay, when you start talking about these things, you're like, wow, people aren't so equal. We started at different starting lines. And so that makes it awkward. But sometimes it's worth understanding a little bit. There's an idea, if you're interested in this, choke is a book about why people practice for something and then choke, meaning fail, on like an exam. Like maybe you're studying for your math exam and you study and you study and you study and then the exam comes and you choke and you fail. Or you're an athlete and you're like practicing your move, you're golfing, you're practicing, and then the big championship you fail. So why does that happen? And it's a whole book about that. If you're interested in that, I can recommend it. It's really well written. But part of the thing is there's this idea of stereotype threat. And so studies have shown that if you are about to do behavior that will demonstrate a stereotype, then your brain is going to spend around 10% of its capacity worrying about that. So in the US, there's a stereotype that girls aren't as good at math. And it's not true, right? But there's a stereotype. And so then they would do studies like they welcome the girls and the boys into the room and they say, we're going to have a math test. Please check the box at the top about what your gender is. And then if they, the people get reminded of what gender they are, and in that test, the women will do worse. But if they bring everybody together and say, we're going to do a math test, this test has been specially designed to have no gender bias whatsoever, then the girls don't do worse. Right? So there's this, or if it's me, in the US, the stereotype is that black people are better at basketball than white people. So if I go do pickup basketball and I'm the white guy and everybody else is black, I'm going to be worried about my doing worse and demonstrating a stereotype, so my performance is going to be worse. Right? So this can happen with all sorts of stereotypes. It could happen between regions of India or older, younger, things like that. Okay, and this is all about group dynamics. I think Prof. Mohit is like, what does this have to do with cognitive engineering? But to me, this is about modeling groups, right? And I just want to point out that these are people that I've formed really nice friendship relationships with over time. And my work as an engineer may not last, right? Especially if you're high tech. You do high tech work and it could be gone in 2 years and obsolete. Or you could do something more engineering, maybe it lasts 5 years. But the relationships can last 20 years. Right? So just as you go through your career, be sure to value the relationships too, and not just be like, oh, we did the thing. Good. Okay, so let me see. I think given the compressed morning, I may skip some slides here. Okay, the last thing I'm going to say is that we're most comfortable with people like us because we have free common ground. If I don't have common ground with you, it takes mental load. It takes mental workload to get the common ground. So our brains are lazy. We want to go as quick as we possible. So if I find people that are like me, then I don't have to do extra work. But I will urge you to do that anyway. Find people who are different than you, that you will do better, right? You will have new ideas. You'll have different kinds of ideas. When I was growing up, I went to an all-boys school from grades 2 through 12. And we had our uniforms, private school, and there was an all-girls school down the road. And I think it took me about 2 years to recover from that experience. I learned a lot, but it screwed up my ability to have friends who were girls. So it took about 2 years for me to learn to have friends who were girls. And when I did, then we started having discussions with whole new topics and whole new outlooks. And I was like, oh, look what I was missing out on for like high school at least. Or maybe junior high we could throw away because your hormones are just out of whack. But there was a lot of messed up, right? And so if you can find other people to have conversations with that are different than you, you'll really benefit. Yeah. Okay, that was it for teams. And I'm trying to think if it's worth, we're going, and the next one is about, oh no, not that one. The next one's about like human AI teams. And I can go right into it, or we can do the break. What do you think? Or we could just stand for 1 minute and stretch and then sit down again. What do you think? Yeah. Okay, at least stand up. Stand up and move your body. Get the blood moving. 10:30? Yeah, okay.
Half an hour.
Yeah, that's right. So we get a little bit of a stretch, get some blood moving, and then we'll do some more again. Yeah. So do any of you participate in Indian dance? Either classical dance or Bollywood type stuff? Okay. So my wife and I do twice a week Zumba and dance fitness. Because you go to the gym, right, and there's somebody moving up front, and it's great because they're usually doing things that it's hard to follow. And so it's a way to work out without feeling bored because you're like, am I moving this way or this way? And then by the time you figure it out, the dance class is over and you were all fit now. But yeah, so I recommend that if you want. Okay, let's sit down again and we'll try a little more. We'll try 30 more minutes. Cameraman is happy. What happened to cameraman? He's coming. Do I need to wait?
Huh?
Do I need to wait on him?
No, actually, he's coming. No, this recording.
So we're good.
Ah, yes.
Okay. I just don't see a camera. But, okay, so I'll keep going. So there's this term HAT. And depending on whom you ask, it's human agent teaming, human AI teaming, or human autonomy teaming. It's a new field, so it's sort of growing, right? There's also human-robot interaction, human machine system. So there are all these terms out there. And this makes it difficult to find all the latest information because you may go into Google Scholar and you're like, I want the latest papers on this topic. And somebody's doing something directly related to what you're doing, except they're calling it human-robot synthesis or human-robot integration, and you're calling it human-robot interaction, and it's different. You know. So you got to do some different terms. Animals are often a good model for AI interaction. So we've got this human and this dog, this police dog, and they work really well together, and the police officer has a model of what the dog can do. I know this dog's capabilities, I know how to order them, and it's a limited scope, right? But it's very effective. I might have a falcon is another, falcons have been operating as human assistants for hundreds of years. And then children, you can model this way too. Right? So if I'm going to have a child who's 5 years old help me cook something, I have to really talk to them differently. Like, okay, we're going to break an egg now and don't drop the shell in the bowl, right? So you have to add things for the children. So they are almost like an agent. And then I put this horse down here. This is a horse race from the United States. And I went to visit the horse race track, and I thought it was fascinating what a great relationship the jockey and the horse have. So the jockey can really tell how the horse is feeling, if they're upset, if they're feeling, revved up. And the horse is not vocal, right? So it's not using speech. So there's a really effective human-agent interaction there with no speech at all, and they're looking at horse posture and that sort of thing. So we have these mental models of our partners, right? And I mentioned this briefly yesterday, so I'm not going to go into it, but I can tell you something, I can tell you, oh, my dad had this stroke, and talk to him differently, and you're going to adjust your mental model. So here's an article. This is often deemed the first article about human-AI collaboration. It's from 1960. And Licklider is a famous MIT professor. And I thought it's worth looking at some of this text. So just look at it for a minute and try to read some text. When you're done reading, look back at me. I'll know. Okay. So I put some red here, in red ink, that I think is interesting. Humans are going to... So a human AI in the future. Well, humans will set out the goals initially in the early years. It's like, okay, is that now? Is that now? Are we now in the early years? And then they will make approximate but fallible and leading contributions and evaluators. So this is what he's forecasting the humans will do once the AI is here, right? Here's another one. Let's read this one. So what's interesting here is this is sometimes called the long tail, and this idea that there's low probability events and there's a lot of them. So let's say I'm making an autonomous vehicle, and the engineer says, well, what are the cases we have to handle? And the cases are, well, we have to handle driving on the highway with a lot of traffic. Okay, check. And that's going to be a frequent case. And we have to handle driving on crowded rural streets with a lot of traffic. Okay, check. And there's a couple things, and those are going to be high in a graph of the number of things you have to deal with. But there's a bunch of other things you might have to deal with, like, okay, what if it's really foggy and you have 2 flat tires at the same time? Okay, that's really rare, but it's something that could happen. And so maybe we need to respond to that. So that's out in the long tail of infrequent, but it's a thing that could happen. And what if I have a duck cross the street in front of me and I don't want to hit the duck? That's really rare, but it might happen. So the long tail is you start out with the frequent things, and those you deal with those. And it's like if I deal with those, I've got 80% of my cases. But 20% of the cases is this long tail of things coming out here that are very infrequent, but to this point they add up to be something you can't ignore. Frequently they call that human in the loop now. What the human in the loop is checking this stuff. Okay, I think this is, okay, we've got 2 more Licklighters. He's using the term symbiosis, and that's a term you often use with like creatures, right? Like a caterpillar and a nearby thing that work together, or there's those little birds that clean the teeth and the crocodiles, sort of thing. So his vision is that we're going to be like symbiosis with AI. I highlighted here of the past. I was like, this is 1960. What's he mean of the past? Human machine systems of the past. I think he's mean like airplanes maybe, you know. Okay, last one. So did he get the future right? He's got these years. So I think it's funny in the first paragraph that he's pretty much like, yeah, I know there are these tech enthusiasts who are saying AI is going to conquer everything and be awesome. He's like, it's not worth arguing with those people. Just like, you know, say yeah, and keep going. So I'm like, even in 1960 he says that. And then, you know, we're going to work together. So he's in 1960. It's going to be 20 years before we even get any useful AI. And then it's, 5 years to have symbiosis and then 15 years to use the symbiosis. What do you think? Is this a correct description of what's happening now or not? Or, what's the symbiosis thing? Is this an even decent metaphor or not so much? What do you think?
That's what we are seeing today.
You think it's what we're seeing now? Yeah, the symbiosis developing. We're trying to figure out like how to work with AI.
It's exponential. The development has been exponential, but then AI it was introduced much before, like in the military, I guess they were using it. So I guess it did take like 10, 15 years to develop.
Yeah.
I would say instead of 1960, even if we put 2025, it's still be decent.
You could do which?
If you replace 1960 with 2025, it could still be the same.
Oh, right. Like even like it's taken longer. Like 2005, it would be the same sort of years, right? 25. Okay. So even currently, you're saying it's going to take some more years.
Right, sir. Will he be alive today to ask if did he really mean this word?
He's not alive today. Yeah. And in the last, he has a caveat at the end. The 15 may be 10 or 500. So he doesn't really know about the technology. But I think it's worth being thoughtful. So he said some things in 1960 that were really prescient and impressive, right? About what the future would be like. Do you think there's anything you can say today about 10 years from now that would be true also? Right? You're saying no. You're like, world's changing too fast. No.
Sir, actually, before the boom of the AI, sir, everyone think that means we should develop a human computer machine which is operated by the human. But after the boom of the AI, everyone thinks that AI can do the work as a human do. So everyone means working on AI to build the system.
Yeah, they're just going to use it, and we don't even need
human intervention.
We don't need the human anymore, right? So the things are changing so fast that I think it's harder to be confident that we could say things about what would happen, 60 years in the future, which is interesting. Okay. So let's look at adaptive automation. This is a concept from the military again, from before there was the AI that we think of today. But it's still useful today. So there's this idea that the system's going to adapt to what's going on. It's going to adapt to you, and it's going to adapt to the environment. And David Caber was a big player in this and said, hey, humans are really good at adapting. Like I'm in a fighter plane and the situation changes and I can adapt really quickly. And so can the systems do that too? They want computer systems to be able to adapt just as well. Jesse Chen from the US Army says, okay, if I'm going to have an agent working with me, I need to have 3 types of information from the agent to have good situation awareness. They always talk about a soldier has good situation awareness. And if you have situation awareness, that means you have information at 3 levels. One is what's going on right now. And number 2 is what is causing what's going on right now? And number 3 is, can I predict the future? And so that's situational awareness normally, and I can apply it to these agents. Like, what is the agent doing right now? And there are some of these video games you can play where you're like, oh, I'm going to go in a campaign, and I'm going to get a wizard and an elf, and the wizard's sort of an AI agent, and I can deploy my wizard and say, hey, wizard, go get me this thing over there. And then I'm left wondering, like, is the wizard doing what I asked? How long is it taking? When is the wizard going to be back? And some of the better games are designed to tell you that information. What reasoning process to use, and you need to be able to predict. So if you're a partner and you say, hey, can you help me out with the literature review? You need to know that you're going to expect a decent literature review back. Like, you need to understand what that's going to do and be able to sort of predict the future. We talked about that already. And here's this adaptive systems framework that's by a paper by these folks. And you end up with perceiving and then selecting an adaptation and then choosing to act. So perceiving the world. Maybe the system changed, like you're running out of fuel. Maybe the world changed, like there's some bad guys that now have left. Maybe the task changed, like, okay, I'm going to switch your goals. Or the human change, I'm getting sleepy, something like that, right? So there's all these things that can change. And then you need some software in there to say, okay, I just saw 3 changes. What am I going to do about it? Well, I'm going to have this agent take over this part of the human's job, and I'm going to add in another agent, and I'm going to automatically do this thing. And it's going to sort of do this big expert decision and adapt. And so here's some examples. If I'm a pilot, I can have adaptive flight displays, and they've actually experimented with things like in stress mode, if things are really going wrong, you might highlight the information that they think the pilots really need. So it used to be there were gauges and dials in the planes, and now a lot of planes have what they call glass cockpits, which is basically iPads or tablets, in the cockpit. And so you could have some gauges that maybe we don't care about the landing gear right now, but we really care about the altitude, so the altitude gauge gets really big, or it gets highlighted, or something like that. In soldiers, so Michael Dornick, I know, who was one of these authors, worked on a thing where the soldier's wearing an EEG hat, so it's kind of doing brainwave stuff, and they had, at that time, this little, it's like a BlackBerry sort of pre-smartphone, and they would have messages coming in, and based on how stressed they thought the soldier was, they would hide lower priority messages. So it's like, okay, I'm going to help you prioritize. And you can imagine that going well or not, right? It might be like, oh, AI, you thought that was low priority, but it was actually not low priority, and now I missed my big thing, So that gets interesting. Oh yeah, this was a drone sort of deal. You can imagine I'm controlling a drone, and maybe the drone can see something that I can't see. The drone is, kilometers away, but I can see something. The drone sees something coming, and it can maybe take over and make decisions. And I'm like, hey, what's my drone doing? So it needs to be good communication there. And then, teachers in a classroom. Teachers in a classroom have a model of how their people are understanding, right? I can look at your faces a little bit and see, are you understanding? Are you not understanding? And you're like, and so I have this constant model going. And whenever you're presenting or teaching, or if you're a theater person on stage, there's 2 things in your brain going on, right? One is you've got some information to convey, like you've got a script to play. And the other is like, are people getting it, right? And maybe you need to adapt. And so it's useful to think that you've got 2 of these processes going in your head, and that's why it's useful to practice talks. So if you're going to give a big talk, you want to practice it so the content stuff is not taking much cognitive load. You're just like push and play, and it's going. And you can use your cognitive load resources to monitor the audience and say, how are they doing, right? And this is true for politicians and all sorts of people who speak. Okay. This is just to say that this is not only me talking about this sort of thing. There are plenty of other groups talking about this. Microsoft has a whole team of people they hire called the HAX team, Human AI Experiences. So they're not calling it HAT, they're calling it HAX. And of course, all these slides are available in Google Drive, you know, if you want. But by photographing them, you're sort of pre-filtering, which is smart too, right? They have a hacks toolkit. So it's like, hey, you're going to design some software that's going to work closely with humans and it's AI, then you should follow our toolkit checklist. That's nice to have. And there's this really interesting paper that I think I put in the folder about, you know, how do you do, like they're analyzing the usability of working with AI. So this is a little bit like, you know, what can Alexa do? What's my mental model of Alexa? So they're saying when you're doing usability testing, people wonder, well, what is this system? What's this AI know and how does it think? And how do I communicate with it? I'm going to skip that. And some of you remember the double diamond from yesterday. So here faintly is the double diamond. And we're doing a user-centered design process. And so we're trying to figure out what are our users' needs and narrow it down to a big need and then figure out products. And so this article, Yang et al., talks about when you use human AI interaction, this gets hard. Here are the reasons it gets hard. So this is a somewhat enlightening article because it's about how hard it is, but it's somewhat frustrating because they don't have answers, right? They're more like, we're going to lay out how hard this is. But if you have answers to their questions, you could be really innovative. You could be the ones coming up with the answers. So at all the stages of the diamond process, they're like, well, it's hard to articulate what AI can do. You get over here, it's difficult to communicate with the time, you know, AI over time. And they did it for the user-centered process and also for a tech-driven process. So here's the same double diamond, but I'm tech-driven. Like I'm thinking about advancing the technology, and it also has these things about why it's hard. So people have been thinking about this even since 2020, right, when the AI was just kicking in. And this is an interesting little graph. So we have two axes. This is about sort of like the complexity of the AI. How many outputs am I getting? And this is about the capabilities. So the simplest thing are probabilistic systems that are saying like, okay, what's the weather tomorrow? Well, given the circumstances, the probability of rain is this. It's not like you wouldn't call it AI necessarily. And then we've got these adaptive systems that are saying, well, I've got my inputs, but I just saw some recent changes. I can give you new information, so it's a little smarter. And then you've got the evolving probabilistic systems that are like, oh, I'm learning over time. I've now got the entire weather database ever in my knowledge, and I've got some simulations of global weather, and then the evolving adaptive. So that's where we're heading, right? Okay, so that I think is where we'll stop for today, for a break. So a 15-minute break, we'll come back for more. Yeah. We're good? Okay. So we're going to talk a little bit more about teams and then get into a brief activity. And the activity is going to be related to come up with an equation to try to measure trust of either another human or an AI agent. So I'll give you more details, but I wanted to tell you about that as an activity because then maybe you'll listen differently as I'm talking. So there are different kinds of teams out there, right? I have some examples. I could have a team of professionals in an office, and maybe one's the marketing manager, one's the IT manager, and one's the product manager, and they have to buy a new cloud-based storage system. So, you know, the IT person knows a lot about it, the others don't really care, they just need it done. So they're coming in, they're somewhat equals, and that's a very different kind of decision than, say, this team. Does anybody do this contest here? It's an activity with students where you get spaghetti and marshmallows or gumdrops when you build a tower. Have you done this? Do people have spaghetti here? Maybe it's not. It's like Italian. It's like pasta. Okay. So it's hard pasta, right? And what we do a lot with the undergrads, I say, here's a bunch of pasta, long, straight rods, and here's little marshmallows or gumdrops or little soft things, and you have to build a tower, you know, and you stick them together and build this tower. And I'll say you get 3 people and you get 7 minutes, build as high a tower as you can. And I've done this with students. It's like the first day of class, and you get a real measure of how good of a team people can be. Because some people will argue a lot and yell, and other people will just try things. And that's a very different kind of team, because you come to this team with no skills. You have no skills in building spaghetti towers, right? As opposed to a military team, it's very hierarchical. We were just talking about some of this. Very specialized skills, similar to a medical team, often hierarchical, very specialized skills. Basketball game, everybody can throw, everybody can shoot, but there's a little variation. So you have overlapping tasks, and that's interesting because your strategy might be like, oh, if she's here and I'm here, I'm going to do this now, but if it's reversed, I do this other thing. And then you have these distributed teams, like with people working together online. And there's different kinds of team tasks. So in the US, this is how garbage collection is working. I don't know, do they have these here, the trucks with the robot arms? So you put out your rubbish bin on the curb, and this truck drives by with the robot arm, and it's like, dumps it and puts it back. And it's a robot arm, and that means that this job is one of the most dangerous in the US because you can, if you get in the way of the robot arm, you are hurt, right? And it's bad. So it's a little bit like a video game task. You could almost analyze that like you analyze your video games. What if your task is cure cancer? You're like, that's a really different task, right? It requires a team. It's not really sure, you're not really sure how to cure cancer. You know some things to try, you know, but it's very different than this team task where you've got 2 people doing the garbage. It's very well defined. I could say, here's a picture of the area of New Orleans that had a big flood. And I could say, your task is to fix the flood, like fix New Orleans. This is also a hard thing, like the cure cancer. And what's interesting here is you end up with these stakeholders with very different agenda. You're going to have the police chief who says one thing, and you're going to have the person who's worried about cows and horses and livestock who are running around. They're going to be worried about something. You're going to have the insurance companies who are worried about something. So all of these stakeholders have to get together. This is a task of assembly line for building a car, and it has a lot of interdependence, right? So if I do my job of installing the dashboard well, then you can do your job of putting the gauges in. But if I don't, I'm hurting your job. So that it's really tight interdependence. Here's a customer service center. You could consider this a team because the whole team may be evaluated on like, oh, everybody gets a raise this month because we got our numbers up. But it's very loosely interdependent. Like this guy can do his job really well, and this guy doesn't have to do as good a job. But maybe they still get raises. So it's loosely coupled. And I forgot. I have this mostly because this was a combine simulator that we built. So it's a combine chair with TVs around. You can farm your corn. And the task here is mentor the child and guide the child in doing something. So there's sort of this mentoring or teaching mode. That's a different kind of task as well because you have to model the people and figure out what they need. So if the question is in a company, should I put team A or team B on this new project? Maybe there's the team over there or there's the team over here. Which one's going to be better on my project? And it could be that team 1 here did really well on task A, And I saw team 1 do really well on task B. So maybe there's something about these people are a good team. And it doesn't really matter what you give them. I mean, maybe there's some tasks they wouldn't be good at, but on a lot of tasks, they're going to be good team. Whereas I've got team 2, and they're really good at this one task, but boy, they sure don't know how to do this other task. And so when you're thinking about this decision in the workplace, you sort of have to figure out which column you're in. Are you in a place where the team may be good at communicating, but they're not going to be good at this other task because it requires specific skills? I could say, oh, here's a really good cricket team. They work really together, but are they good at cooking a big meal together? And it's a different task. So let's look at human agent teams. And I could be a single human with one agent, like it's me and Alexa, or me, something, or me and Gemini. Or I could have multiple agents. I get Alexa and I got Gemini. Maybe I want both, because I want music in my background and I want help with my homework. I can have 2 people sharing an agent. And you get into interesting questions like, what if I'm a team and we each have Gemini? Should my Gemini know what your Gemini knows? Like, should we be able to link? So I can log on and be like, here's Copilot or Gemini or ChatGPT, and maybe I should be able to share with friends and have a team, and then all 3 of our ChatGPTs know about each other and share memory. And so then my ChatGPT can say, well, Upal said this last time, so you need to watch out for that. Don't you remember that? That was a thing on your team. Nobody's really talking about that yet.
When you're talking to Gemini, I used to understand that Gemini across the world is the same. It's the same. Like, is it?
You're saying, is it the same across the world?
I don't know.
So they vary a lot. You get issues like Siri on a watch is different than Siri on a phone, is different than Siri in your desktop, because they have different levels of smarts. And they will do different behaviors because there's the cloud, and some of it's in the cloud. But then there's also things like a company, like at Iowa State, for example, we've bought all the Microsoft things. So we have Microsoft Copilot. And our version of Copilot at Iowa State is protected to just Iowa State. So it knows all the stuff from Copilot, but I can feed it information about my Iowa State projects, and that won't be public. So it's like got a little wall around it so that the people at the other universities can't see my stuff. See what I mean?
So if I use Copilot here and you also use Copilot, we would still get different answers from the same.
We might get different answers, yeah. Especially if I fed it more information about my work at Iowa State. Yeah. And you can do these things, like it's pretty easy to go and to add agents. I can, was I telling you about the avatar posters? The poster avatar people? Yeah. So yeah, it's pretty easy to feed an agent information. You can say, like there's a website called Zapier, which does this, Zapier. And you can go to Zapier and it's like, which agent do you want? Gemini, ChatGPT, whatever, you pick ChatGPT. And then it's like, what do you want your agent to know? And you can copy paste information into a text box. And all of a sudden it knows all that. Then you can say, what's your audience? You can say, I want my agent to talk to middle school kids and to sound like a pirate. And then your agent will always sound like a pirate talking to middle school kids who knows this information. And then you can do that in like 10 minutes, right? Okay, so we talked a little about all these times. There's this talk about, is an agent a tool or a teammate? So an agent could be a tool, like Alexa is more like a tool, like play me this music, what movie is playing nearby, what temperature is it outside. It's just a tool for me, information tool. But I can get a complex agent like, hey Alexa, you know the bands I like. Like I can't do this yet, but ideally I would say, you know my favorite bands, which ones are playing in a 100-mile radius, get me tickets, that are a good price but not too expensive. So one of the papers I worked on for research was, as we started to think about agents and what they do, we realized that there are a lot of video games that have agents in them. And there are a lot of these video games where you're playing a role in the video game and you have characters that can do things for you, like AI agents, like help you fight or something like that. So we went through and wanted to analyze all the video games we could find that have autonomous agents and that are human agent teams. And we came out with these following characteristics of human agent teams. And some of these are popular in the literature outside us, and some others are just us. So level of automation is something you'll find in the literature broadly. In cars, they talk about there's 6 levels of automation, but in like airplanes, it's more like 10 or 12. And if you have high automation, the agent can act on its own and take initiative. If you have low automation, the agent might be like, hey, you ought to do this. Type of interaction, control mode, is it like a coworker or a servant? That's more of a term from us. The timing, the interdependence is an interesting thing. And then we propose these agent types. So here's an example of agent types. Oh no, first here's automation. So here's 10 levels of automation. So in the middle, I think doesn't it add a thing? Yeah. So there's opt-in or opt-out. Opt-out means the agent is going to take initiative and do something unless you say stop. Opt-in is it's going to recommend things, but you have to opt in. So, the top is the agent's just ignoring the human. Okay. Here's a Madden 2021 football game. And in this, it's going to loop here, so we'll see a couple examples. But you see 3 kinds of agents. So here's the football, and you're carrying the ball, and right there it says juke. It's like you should juke now, which means sort of like, I do this sort of thing. So this thing is recommending, it's like an advisor. So let's watch for the juke again. They throw the ball, this has the ball, and it's like a little blue thing, like you should do this. But now this part is when it goes back to the dashboard, it's the planner. The planner is like, well, I'm an expert coach, and I think your next play should be this play. So here, it's coach suggestions. So it very briefly has 3 plays. So that's a different kind of agent, right? And then the last kind of agent is just all the other players. Those are the actors. I mean, all of those football players are under AI control except yours. So that's another kind of agent. So we ended up categorizing these kinds of agents and tried to put in the characteristics of each one. Here's another example. So this is a game, and you have to sort of shoot the bad guys in the tanks, and watch down here. You've got some people down here. And this is a single player, so you're controlling this whole troops. So it's like you move them, and they follow you. And then you're going to switch perspectives here in a minute, because there's like a tank over here. So now you're on the street, and you're like, I'm going to go switch. Here's the tank. And I'll blow it. Okay. So this is another form of human agent team, right? I've got these other agents that are following me. And what we can do is analyze the game to show how is it helping me understand what my agents are doing. Like that's the key thing you want to know. I'm on a team. How do we know what my teammates are doing? How do I know what my AI teammates are doing? Well, here I can just sort of see them. That's great. Maybe I need to know some status down here. Like here's my health status. Maybe I need to have my health status for my teammates too. How are they doing? And so you end up with research areas that are things that sound very non-engineering. Like we talked about trust. There's also etiquette research. Like what should the etiquette of ChatGPT be? Like right now we've talked about it sort of flattering, and that's in the past 6-8 months. They've added that in. And I think it's a competitive thing, right? Because if I use ChatGPT and it makes me feel good about myself, then maybe I want to keep using it instead of Claude or Gemini, because maybe it doesn't, I don't know. Yeah. So here was our study where we analyzed all these games. We had like 88 potential games. We review the games, get it down to 13 games. We analyze them. We have themes and then design patterns. Design patterns are sort of recurring patterns that we see across games. And so we ended up with these gray patterns, 25 different patterns that we would see. So when you're starting out your campaign, there's often some pre-planning about what do I have in my inventory, where am I going to position myself. And so what we saw across multiple games, all 13 games, was they would have user interfaces to do this. So our question was like, what user interfaces are helpful when you are doing all these human AI tasks? And the Air Force was paying us to do this because the Air Force has software that manages drones and surveillance. And it looks like it's a 1990s video game that was really badly designed. It looks terrible. And so they say they want to update their software. And they're like, go get the best of the best from the current game world. And so, example of design patterns from Fortnite, for example, okay, most of them are going to have a compass for navigation. Most of them are going to have a mini map to help you know where you are, right? So those are just examples. Okay. So here's what comes with the major challenges of human agent team stuff. One is measuring things. You'll have this continuing measuring thing from me about how do I measure stuff that sounds fuzzy. And then authoring systems. So if I'm authoring those video games, I need to program agents that will know how to react to a variety of circumstances. So can I think of all possible circumstances? I don't know. Maybe I can, maybe I can't, depending on the domain, right? So let's say you want to book and so I want to introduce the concept of service design to you as a useful framework. How many people have heard of service design? Okay, so a couple people. All right, so there's product design, service design, right? And services are like, I go to the hospital, I get healed. So they did a service for my body. I book a flight and I flew, but I don't walk away with a new product, right? I just had a service. And so there's this idea of touch points. So if I'm going to go book a flight, there's all the touch points. I go to the website to book a flight. I check in at a kiosk. I talk to a human. I go and look at where my flight is. Maybe I read a magazine in the plane. I sit in the plane. I have to find my seat. And talk to a flight attendant. The whole design of the airport is part of the experience as well. And then I get my baggage. I may look at the app. And I can talk on the phone line. All of these are touch points. And I have good service design. Then ideally, I have a good experience that's consistent across all of them. So the touch point idea comes up a lot with the human agent teaming. Like, how am I going to interact with the AI? I have these different kinds of touch points. And then the other ideas in service design is this front stage, backstage, and infrastructure. So in a theater, I've got the people seeing the front actors, and I've got in the back, there's people controlling lights and props and sound. And then in the very back, I've got people with like payroll software and who's showing up today to work. And similarly in restaurants, I've got the front stage where the food comes out. I get the food experience. I've got the backstage kitchen. And in the very back, I've got, refrigerators and inventory and payroll. So now let's imagine that same concept for human agent teaming. I want to create the ultimate AI textbook for students to learn from, maybe. So I've got this student learning online, and maybe they're going to use something like Comigo, or they're going to use some cool AI tool. So what am I going to program on that? Maybe I need something of like, hey, if the student says this, then say good job. But if the student does this, I say, well, you should try focusing on this thing. How are you going to lay that out? And are you laying that out explicitly, or are you letting an agent like an LLM just sort of deal and take care of it? Maybe you say, here's the good answers, here's the bad answers, smooth it over, come up with the stuff in between for me. And this is what I would call the authoring of the system. And the hard thing is that it's a linear experience, right? The human is having a linear experience over time. I'm interacting with this agent, but the whole back end computationally is very branching, like all the possibilities that might happen. And as an example of this, if you go to a museum exhibits are typically not linear. So the museum exhibit, whoever designed this exhibit, maybe it's on dinosaur fossils, had some goals for you to learn. Like the exhibit is a learning experience. But they need to have you learn these goals no matter what order you walk through it, and no matter which direction you go. So they want you to walk away with the idea of like, oh, fossils are constantly changing and we need to, learn about them all the time. And dinosaurs were sure big, or something like that. They have learning goals, and you're going to maybe experience them in multiple ways as you go through. So I think exhibit design, there's a whole field of exhibit design, and I think it has something to tell us about these hat designs as well, because of the non-linearity. Okay, so there's the agents. Oh yeah, and I have this example over here with the team tutor. So we have built tutoring systems where we have different people doing a team. We did a military example where we had 2 surveillance spotters. They were standing on top of a building, and you were supposed to watch for bad guys running around the village. and then there was a person with binoculars in a tower. And so it's like one of the spotters would say, hey, I think I see a guy who might be suspicious. You know, hey, tower person, go look at this person. It's at 2 o'clock, tower. And the tower person would say, okay, I looked at him, he's okay. And we would have a tutor agent for each of them. And then we had a team tutor that would say things like, y'all are not very good at acknowledging communications. Y'all need to say more times when you communicate, you need to say acknowledge, over. You need to say these sort of things. So it's a team tutoring thing. So we were one of the first people in my group to build an actual team tutor with multiple agents for everybody on the team and a supervisory agent. Okay, so now let me switch now to my, I'm switching to the part that we would be doing in the afternoon. So this is going to be the activity. About trust in AI. So first I have more text from the past. Creators of media should be outlawed. They pretend to know things, but they know nothing. They are imitators, and they're the worst. Anyone know who said this, or when they said this? Where does this writing come from? Any guesses?
When AI was just starting out.
Sorry, which?
When AI was starting out.
Maybe when AI was starting out?
Yeah.
Older. I'll go older. What were you saying? When? What?
1984.
Maybe, oh, George Orwell, 1984. Maybe. That's a nice idea. Pranav might know, too. Didn't you mention him some philosophy background? Didn't you have some philosophy background?
Yeah.
Okay. So you might recognize this. I don't know.
There was recently a same kind of article written by some linguistics student suggesting these are copying agents, AI, like that only, it works like that only. And I want them to do macro rows like washing and doing that. So there is one this, and also I forgot there is surrealist I think the surrealist Satya or someone who also suggested this. And
So multiple people have said things like this, right, about this. And just to give a flavor, this was from Plato, 390 BC, right? So it's like way back, people are worried about the media. You know, they're worried about deep fakes and everything. Okay, here's another writer. So because we've got the word information and we got the word universities, it's not as old as Plato, but it's still old. This is pretty much like change the universities or get rid of them, because now we have books. We used to not have books for everybody, but now we have books for everybody, so you don't need universities. You know, right? And you know, people need all the full information to throw off the despotism. So a lot of, you know, this person would probably think if you said, hey, there's this internet where you can get any information you want, they would say, oh, great, no more despotism, not realizing that we have now conflicting information on the internet. Okay, so this was from this guy, Vicesimus Knox, 1700s in the UK. So these concerns are old. This is about trust, right? So here's your assignment, and I'm going to talk some about it more, but you're going to propose a trust score. We're going to do it in groups of 2 or 3 again. So first, think of an interaction with a human that makes your trust increase or decrease with that human. Like, oh, I did this with a human and my trust got better or got worse. And then 2 interactions with an AI agent that maybe makes you trust it more or less. And then this is the hardest part. Then I'm going to suggest you propose a way to measure trust somehow. But it may just be one piece of trust. Like I think you need weeks to come up with like the whole all trust. But you can just measure a piece of it. And then try to use your equation to go back and score your 3 interactions. And so let me give you some examples. So first, what do I mean by an AI agent? Here are at least 10 kinds of agents that I could argue are AI agents, right? The interactive walkthrough is you open up some software you've never used, and it's like, welcome, your save button is over here, and you hit next, and the little thing moves, and it's like, and this is where you change your settings. And then there's the smart form fillers that are like, oh, it's Stephen again, and I'm filling out the form, and it auto-fills Stephen in my address. And there's the old chatbots before there was LLMs, right, that are like, what's my bank account? Path recommendation agent is more, it's analyzing what you're doing in a website, and it's like, you probably want to click, do your invoice now. AI search assistants are both, that can be, when I type something like camera, it's going to decide that I probably want to buy a camera. So it's going to give me hits on buying a camera as opposed to fix a camera. But if I type fix a camera, it's like, okay, I'm going to give you hits. So it's a little bit of using AI to make assumptions about what I'm searching for. Context-aware behavior is a little bit similar to the path recommendation. It's looking for my behavior, and it's going to say, oh, it looks like you're stuck. Looks like you need to do X. Predictive analytics is more about business and data dashboards. You have these data dashboards. It's like, oh, in your next business quarter, you might consider selling this product because of its score so far. The voice assistants are like Siri or Alexa. Multi-agent system, this is a thing in our list, but I'm not sure of a good example of it. I think it's just this idea that I'm working in a system and there's different kinds of agents that do different roles. And then we've got the LLMs that can be embedded like everywhere. So, and this arrow about less smart versus more smart, it's really rough. It's not really linear because some of these are different kinds of categories. So that's when I say back on here, think of two interactions with an AI agent. Your AI agent could be any of this, right? I realized I thought I had recommender systems in here. So, Amazon will be like, oh, you bought this product, you might want this product. Or Spotify, do people use Spotify here? Yeah, okay, so Spotify will like, hey, you might like this song. Huh, maybe that's under context-aware behavior agent, but yeah, the recommender systems are in there too.
So, superficially, how do we understand the difference between LLM and non-LLM?
I think the LLMs, yeah, good question. The non-LLMs have somebody programmed them with a set of questions they can answer. Like they can answer, what's my bank balance? I would like to make a withdrawal. They came out with banks a lot first, or travel agencies. They know how to say, how cheap is the flight to Delhi or something. So it's pre-programmed with the questions it can answer. And the LLMs are not. They're sort of free-flowing, and they just have the whole knowledge of the internet available. Does that make sense? Yeah. So I think in terms of trust, the non-LLMs are a little more trustworthy. They're not hallucinating. They're frustrating because you're like, I want to stop my certificate of deposit and restart it in a week. And it's like, that's a weird case, and so it doesn't cope with it. And it's like, I don't know what you mean. So they're frustrating that way, but they don't make mistakes, right? They will tell you that, like, I don't understand, but they won't make mistakes. Like the LLMs will just tell you, like, yeah, mangoes are purple, yeah. And you're like, what? Yeah. Okay, so I asked you to make a trust score, and you're like, what's a trust score? So we talked before in another class about how there's stuff you want to measure. Like, I want to measure how much these humans trust this agent. How much do you trust ChatGPT? But I can't put electrodes in your brain, so I'm going to have to come up with a proxy, like some equation or is there something I can count? And so here's some examples. Maybe I decide with Alexa that I want to measure something about familiarity. My level of trust in Alexa is about how much Alexa's using knowledge it has about me, because if it uses more knowledge it knows about me, then I trust it more, because it knows me. And so I decide that I count up all of its responses, and I divide out the number of times it uses facts about me. And I call that familiarity. And so I might have a transcript where I'm like, hey, what's on my calendar for tomorrow? And well, you have 5 meetings. The first is this, da, 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 da. So it used 2 facts about me, and it's going to score higher on this trust measure, right? I'm not saying like this is the right answer or a great thing at all. You might say, well, that's a terrible measure of trust, Stephen. I don't like that at all. I'm like, great. But it's an example of an equation that you could decide measures something. Or you could decide, I don't like that equation. I want to do something else. But this is an example of applying it, right? I have an equation, and then in your scenarios that you're writing up, maybe you have a little dialogue, like a transcript like this, and then you tag it up and you score it.
Here it's like 2 by 3.
That's right. Here it'd be 2 by 3. So I've got total responses. Well, yeah, I could do, if I count sentences, maybe I got 3 sentences, and 2 out of the 3 sentences use facts about me. Yeah. Here's a different one. Maybe I decide that in the military, they always teach you to say acknowledge afterwards, after some communication. So you tell me something and I say acknowledge. And so I'm going to decide good military communication. Maybe that's only the US military. Anyway, we're always saying acknowledge. I decide that good communication is percentage of times you say acknowledge after their communications. So if I say, hey, you need to transfer something, and then I say acknowledge, and then I say, somebody else says again later, transfer this thing, and I say acknowledge, then I've got 100% here. Well, the reason I use this example is because timing could matter. You might decide, well, actually, this is not 100% because I didn't say acknowledge in here before the transfer, right? I got like transfer, acknowledge. So you could say, oh no, they messed that up. So if you think that's a mistake, then my formula is probably not the best, right? But if you think that's fine, the formula could work. So I hope this illustrates the idea that it's hard to come up with formulas that are great, but give it a shot because it's an interesting activity to try. And then we're going to go back and we're going to all add them onto this Google Doc. So this takes you to a Google Doc where you can add in your stuff. Does that seem clear? Also, I think you got the message from, you sent out to the chat the other Google Doc to add your stories. So we don't have time today to go into the speculative fiction, but I hope you'll add them and then we'll read each other's and talk about them tomorrow. Okay, do you want to do this? Do you want me to assign groups again? Or you want to pick your own groups today for this? You want what?
Assign the group.
Assign the groups. Okay, so we have, you want to be in a group? Yeah? So 1, 2, 3, 4, 5, 6. You gonna do this?
Sir, I will do individual.
Okay. Group is harder. It's a better test, if you want.
No, sir, tomorrow I will come with my roommate and we will do.
Okay, that's fine. That's fine. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're gonna have 6 groups of 2 and 1 of 3. And so you're 1, you say 1, 2, 6, and you're 1, you're 4, he's 4, 5, 6, 1. Okay, all the 1s, raise your hand, get together. Maybe over by him, there's more chairs. 2s, who's a 2? So you all get together. It's just 2 of you. 3s, okay, y'all get together. 4s, y'all get together. 5s, okay. 6s.
So you have to do right now?
Yeah. We're gonna do it right now.
I thought you were going
I'm
to
sorry.
as the assignment.
No, I get that. Do you want to do it with a group now?
No, I can't.
Okay, so why don't you join the 2s? The 2s, you can join with them. Who's a 2? Okay, so join those 2 guys. Okay, so let's do this for, this is going to take you longer than you think. Okay, go for it. Yeah. What?
So, what you do from plateaus? So, there was a person, I'm at 2-3 years old. So, she was seeing thing of the plateau road and I asked if I been to the plateau or I asked a lot of like plateau, then deposit salmon juice, never been to any of them. But she wrote something which is very similar.
Very similar to Plato. Okay. Cool. Cool. Send me that. Okay. Okay. Why don't you move to be near your group people? Yeah. Go. Yeah. Be sure to introduce yourself if you don't know everybody's name.
So let me bring my laptop.
Yeah, that'd be great. Do you understand? Yeah. What's your thought? Do you understand what it's asking? Okay, you're good. Okay. You okay?
I didn't get it said that easy. So the second task,
Yeah.
could you please explain a little bit the assignment to me?
Yeah, on the second one, so there are these different kinds of AI agents,
ChatGPT, Gemini, DeepSeek.
or any of those 10 that I've been over. Even like
I
a,
have chose the 10th point because ChatGPT I have used a lot, so I know about ChatGPT.
so that's okay, unless you can't
That's
think
okay
of,
now, or I
unless
have to
you,
choose one from first.
no, you can do any of them.
Any out of 10.
Yeah.
I chose the 10th one. Okay.
Yeah.
Then
And then think about an interaction that you've had that makes you trust it less, like maybe a ChatGPT lies to you or tells you something that's false, and so then you trust it less.
okay, so I have
And
to have a convo with ChatGPT, but not related to facts or something. I have to be emotional or something that is situational based totally.
I mean, you can do it however you want. It has no
That is
requirement
the
here.
way. Na? Acha, I can do that way.
You can do it that way if you want.
Okay.
And it can, any sort of conversation you might have that makes your trust increase or decrease. And then you are going to write out that conversation. And we need 2 examples. And then when you get to part 3, you're going to propose some way to measure the trust.
Okay.
And then on number 4, you're going to go score it. So you're going to say, oh, my measure of trust is something about how many times it does this versus this. And I scored this thing on ChatGPT, this conversation I had, and that makes me really hate it and not trust it. Or this makes me really trust it because I did this and this and this. That makes sense?
And the deadline for the project is tomorrow 2 p.m. Or today 2
No, I mean start now, but then tomorrow 2 p.m. Yeah.
Or till tomorrow.
Yeah. Yeah.
Got it.
I'm going to make another announcement. I don't know if it matters. So I'll just say that you can pick from any of these. You know, I just said these are different AI agents. You don't have to do them all. You can pick from any of these you want. These are just different kinds of AI agents. And then the other thing is, ideally, your trust score would work just as well for your human AI trust as it would for the human trust, right? Because you're going to have some interaction where like, oh, I asked the person to meet me tomorrow and they didn't show up, and that decreased my trust in this person. And then I asked ChatGPT to do X and it didn't work, and I did, decrease my trust or whatever. I don't know. So, yeah. So then and this is just like all the other activities. This is due tomorrow afternoon at 2, but start now because you'll have questions. Okay, any other questions now?
Do you have a class today at afternoon, or do you have a meeting today?
Yeah, there is no afternoon class today.
Okay.
Yeah.
So will Mohit sir take over from me?
No, there's nothing this afternoon.
He said that there is a class in afternoon.
So it's not just ChatGPT, right? It's also like recommender systems on Spotify that recommend a song.
Generative AI and agentic AI.
Well, that's number 10, but all the 1 through 9 are not that. So like if Spotify recommends a song, that's a type of AI too.
Spotify.
Yeah, like, you know Spotify, right? Yeah.
Yes.
Yeah, so Spotify would be number 6.
Context aware behavior.
Yeah, like it would be, or Amazon recommends a product to you, that'd be like 6.
Better user experience recommendations.
Yeah, ideally, if they're good recommendations, yeah. So there's different kinds of AI. So you can pick any kind of AI. It doesn't have to be an LLM. Yeah. Or it could be Alexa, you know, Siri, one of these. Which one?
So these are voices.
Yeah, those are like the voice assistants, like number 8.
So what is this difference between context aware behavior agent and predictive analytics agent?
The predictive analytics is more like data dashboards for business, and you've got all your data about your car sales for the past year, and it's
Previous data
we're predicting and forecasting. Yeah, it's like, hey, you should sell this car next year. It's going to sell well, or something like that.
So these are useful in businesses.
Yeah.
It's a multi-agent system.
That one, it came up in a list. I got this list from a text, and I'm not sure about the multi-agent system, honestly. I think it's more that.
Agentic AI side of things.
I think it's more for military context, where like I'm trying to control 3 drones, and the drones all have their own AI, but they're not talking to each other. So it's like, yeah.
Sir, in China, we can take an example. Sir, in China, there is a drone show. Lots of thousands of drones are.
Yeah. For lights and all that. Yeah.
That can be a multi-agent.
That could be. That's a good one. Yeah. So these are some AI flavors you can pick from. So it's not just, ChatGPT. And then here are 2 examples of a trust score that I'm not saying are good examples. I'm just saying they are examples. One is maybe I decide that Alexa is going to be good if it has more facts about me when it answers. So then I look at all of its answers and I say, how many times did it reference facts about me? And I'm going to use an equation like, the more the better. You see what I mean?
How fast it gets trained? Is this
Not for the training, but when it answers, like I'm just talking to Alexa, and
while talking you are training, I guess. While talking with Alexa, it gets trained by talking, knowing your behavior, and then responsive.
So sometimes.
Responsive next answer on the basis of previous behavior of the user.
So sometimes. I wouldn't worry about that though, right? Because sometimes Alexa's taking your data as training, and sometimes it's just responding. Like you say, what's the weather or whatever, it just, knows. But that's an example of, I try to have an equation to measure some form of trust, and then I count up and I score it, right? And then here's I'll wait on that, yeah. And I'm not saying this is good or true or anything, right? I'm just like, here's an example of I'm trying to score something about trust, and maybe it's going to work or maybe it's not. You good? And here's another example. In the military, they'll say, they want you to say acknowledge after you talk. So you might say, good communication is every communication is acknowledged. So I'm going to have the percentage of communications that have acknowledge after them. Maybe that's a good measure of communication. And so then where it gets interesting is if I have one soldier says transfer, and the other one says acknowledge, is that okay? Or is it really like the equation needs to be, you need to say acknowledge within 5 seconds, right? So currently the formula would say, that's good, 100%. But if you want it within a certain time, we have to change the formula to be like number of acknowledges within 5 seconds. So that's just an example of these equations. Okay. So now you've heard what everybody else heard, I think. And then that's the Google Doc where you put your work. Okay. Yeah. some of the students were like, "Oh, Prof. Mohit's going to come teach something, so we should show up." And I was like, "I haven't heard that, but I don't know, whatever."
You want to take your tutorial? Second half?
No, I'm okay. I don't need it.
One second.
I'm okay with what you said. You, you know.
You have done your masters. So how many of you do not know the ergonomics basics? I guess there's four for sure. You also do not know. There's year one, two, three, four. Three here and this side. You know ergonomics little bit?
And I just know the superficial basics of that, how to calculation, very basics.
Okay, because this is a bit application oriented. Okay, so I'll teach about the ergonomics very fundamental things, very basic. Okay, maybe like what you have studied might be in your initial classes. So from that I'll start. Okay.
Was there a group photo or something? Okay. There may be a group photo.
So you mentioned this trust. We are trying to discuss this trust. So like when we go through literature, trust is almost seen like a philosophical concept and that goes somewhere else. In terms of philosophy of they have a concept of trust.
That's like the psychology side, but there's also this behavior side of
So
what are the trust behaviors.
You had shown some slides where you mentioned someone has done some paper or article on trust.
Yeah.
So you would recommend that to understand it in terms of practical,
Right.
measurable,
Right.
like metric way of. So I'll go.
Yeah.
That is a paper that.
Yeah. Anything by Lee, if it's about trust and it's by Lee, Lee is good. And Lee has a couple papers. I think there was Lee and C, and then there was Meyer and Lee, I think. And I think they're both in here.
The one you sent in the readings.
Let's see, do we have... Oh, do I not have it in there? Oh, here's a Lee. Well, that's Lee and safety. Okay, I don't have actually the Lee papers in here. I'll go put those in there.
Yeah.
You don't need them for this necessarily, though. I mean, this is more casual, but...
Like the why that question also came is like it depends on the setting where we are trying to measure trust, and trust can have different components. Like here it was familiarity, and where somewhere we are just looking at the factual correctness of the interaction, or like now we'll have to understand trust in which facet or which.
I mean, you can pick the facet. I think it's something like, let's say you're at a company and the company says, oh, we need a new AI for our software, and be sure customers trust it, because I don't want some AI agent that people don't trust. So then if they say that to you, you're going to need to have in your head, like, how am I going to measure that trust? So then you got to come up with something. Does that make sense?
Yes, and we need some starting point or some frame of reference.
Well, you can make it up then, right? But it's about a task. It's about the task.
Like first we have to scribble down the experiences or interactions, right? So from that interactions or experiences, we have to identify how we are going to measure that trust or distrust.
Right. Yeah. So you might even just, I mean, it's easiest to start with anything like brainstorm an example of some interaction with another human that made you decrease trust or increase trust. And then you look at, well, what happened there? Oh, the key thing was that they said this under this circumstance or something like that, right?
So when you came to India,
Yeah.
you must have come several times.
This is my first time.
So what is your trust? You must have met several people across the country from that point where you entered India till here.
Oh, yeah, right. Oh, yeah, good question. So there was when I was in Delhi, I got an Uber from the airport to a restaurant, and that was great, and that was fine. And I trusted the guy more because I didn't. In the U.S., when you get Uber, the Uber app pays for the ride. Like when you accept the ride, you pay instantly. But this guy was like, "Oh, I take cash only, so you can't pay in the app. You have to pay me cash." So at the end of the ride, he's like, "Where's my cash?" And I'm like, "I don't have any cash." He's like, "Well, I'll take you to an exchange place and you can get cash." So he was happy to do that, and he was patient while I got cash. So I thought that made me trust him a little more because he understood that I made a mistake. I didn't know how Uber worked. So he gave me the benefit of the doubt. He was waiting for me to get the cash, right? But then, and so I trusted him more. But then later I was going to my phone died, so I couldn't get an Uber back to the airport hotel. So then I'm like, well, I'll just go find a cab. So I go stand on the street. This guy comes by. I'll take you to the hotel. And then, no, different guy. And so I get in, and I should have said, how much will it be?
That scam we all fail.
Yeah, exactly. But then I didn't do that. So then I get there, and he's like 500. I'm like, what? I'm like, no way, you know.
Just paid, so you knew the actual rate.
Yeah, I had just paid the Uber guy. I was like 200, and I'm like, okay, it should not be 500. He's like, well, I'm like, okay.
This kind of scam is happening all the time.
Yeah.
I have also fallen for the same kind of scam. Like, he was like, just get in. I will get you to the destination. When I got to the destination, I say how much they are. So he will take like, it was around 250. I can came by the public transport bus by 10 rupees.
Yeah, right.
So you're asking like 25 times more than the.
Yeah. So that decreases my trust in the cab drivers, right? Yeah. So maybe that helps you. I don't know if you can put that into an equation. Yeah. Yeah, okay. Are you having okay? Doing okay?
Yes.
So let's start.
So for the first one means if suppose you are means I am a seller and you are a buyer.
Sailor and a
Buyer. You are a buyer.
buyer,
I am a
seller and buyer. Yeah.
seller, I am buyer. And so suppose if I am marketing my product to you,
Mm.
so then you can understand whether I am means lying or telling truth.
Yeah, sure.
So if I am lying about my product, then sir, your means trust score will decrease. Means sir, you
For
will
long term.
That's right. That's
yeah.
right.
And sir, if means you generally know that I am talking means I am talking real about the product. These qualities are genuine. Then sir, you we means there is a trust between us.
Trust score increase.
Yeah,
For
that's right. That's right.
Yeah.
Those are good
the
examples.
human to human interaction.
That's right. And I would make it specific, like I'm selling food or I'm selling saris or something. Like have a specific example. And do I realize you're lying later when I get home, or do I realize you're lying while I'm still in the store?
Sir, means
You know?
Both depends on person to person how
Yeah.
smart he is. How
Yeah. Yeah.
means you can lie after using a product. Means you can assume that he is maybe lying. Means he is lying after using a product. You are sure. Then sir, that successful means negative.
Yeah.
That's,
Yeah.
and sir, and second means AI agent. Sir means suppose I give a prompt to ChatGPT.
Yeah.
It means a specific question I give to ChatGPT and it may give answer, but not up to the mark that I was expecting.
Okay. Yeah.
satisfaction level
Oh,
of the
okay.
user.
Yeah.
Satisfaction, my satisfaction level decreases. Then I means get means
Then
I
we have to re-enter the prompt. Then again re-enter the prompt. That's how the trust score decreases.
That's interesting because then your measure of trust is a little bit like number of prompts you have to do to get what you want. Something like that's a nice
We
idea.
want the measurable metrics.
Yeah.
So I guess satisfaction level is the good measure.
That's great. I like that a lot.
Trust is basically emotion, not anything.
Yeah, that's
One
good.
of the emotion trust.
Yeah. Before you were here, we went through a bunch of concrete behaviors that lead to trust or mistrust. Yeah.
and sir, if it gives us a personalized idea, means it see my chat history, and sir, it gives me answer that I was thinking according to the AI. Then sir, my satisfaction level increase. That yes, the answer is according to my thinking.
Yeah.
For example, if you ask to ChatGPT for validation, it will always say right, right, right. But there's a problem is this confirmation bias came out. Confirmation bias means what we are thinking
Yeah.
is true,
Right.
and we neglect the other aspect which causes us long-term problems.
That's right. That's great. Good
Basically,
insight.
While I do user research now, I took questions from ChatGPT and ask, but I make sure that I will not suffer from confirmation bias.
If you can avoid it, yeah. So those are all great examples. I would write this up. I mean, you're almost done, right? Like you could write this up and then just try to be a little specific. So instead of saying I asked ChatGPT something and it didn't give me enough, like give me an example. Like I asked ChatGPT for why are Pakistan and India fighting, and it gave me 2 paragraphs, and that's not enough, or something. I don't know. Yeah, but just give a specific example. Okay, cool. Y'all doing okay?
Okay. So, good afternoon, friends. So, this is the lecture number 8. We are going to discuss about the introduction to human factors, right? So, as I told, human factors and ergonomics, both of these two words goes parallelly. Okay, it's not the separate one. But there are, like in India, if you talk about, so here basically we use alone the term ergonomics, okay, not the human factors. But outside India, mostly in that American side, that areas this term goes together, right? So human factors and ergonomics both. So we will see. First, we will start. Okay. First, how this particular discipline has been evolved. Okay. So if you can see the origin when it is started or came into existence, about people started thinking about the human factors and ergonomics. So near about 1900. Okay. So that time, but what was the focus at that particular moment? So early focus was on the work efficiency and the error which human were basically making. So that was the first about which people started thinking, apart from the other parameters. Like before that also, human being was interacting with the machines or the overall systems. But this is the time when the what was the problem in the human being and why this error is happening between the interactions and the system, that has been came into picture. And that particular moment, so the areas which were considered, that was the lifting, simple lifting task, or the repetitive task which was performing. Repetitive task means something work that has been performed in a repetitive nature. So that particular kind of the task initially started. Then we are talking about the industrial ergonomics. The era is some around the 1900s to 1940s. Okay. Then World War II, 1940 to 50. So as it goes, the evolvement in that area grew. Okay. And the area of this study, that also changes or given more importance to the other parameters. As you can see, the fifth one, in which era right now we are, okay, and the sixth, which is going to be the future. Already the AI is came into the existence, and people have started thinking about that parameters also along with the human factors. Okay. But let's say the first discuss about this contemporary ergonomics. So user-centered design. So again, the user means the human being who is interacting. So user-centered design, computer interactions. Already these computer interactions, the part of the cognitive application in the digital interface, because most of things are digitized. Okay, we are shifting from the manual system to mechanical system, then mechanical system to the automated system. So these are the different types of systems through which we are moving. So as we are moving towards the automated system, so this digital interface, then the wearable techniques or the smart workplaces. Okay, smart workplaces, as early in the morning you had one video, right? The automatic, the car. So that could be the one environment. Okay, or the wearable techs. Okay, so different gadgets, and along with that, how we are basically dealing with. Okay, so again, when we are dealing this high tech technology equipment or the workplaces, then what are the growing areas that is affecting basically the human beings? Okay, so MSD, musculoskeletal disorders, the full form of this, that is the posture. Posture is nothing but the how overall positions we are making while performing any activity. Then HAV, hand arm vibration. This is basically related with the some vibrating equipments if we are dealing with, let's say, the drill machines or the grinders at the our home appliances if we see. Okay, so this kind of things. So this is the one small examples. But in a industry side, let's say that stone crusher or that the tile polishing. Okay, so these are the different devices with which are handled by the human hand or operated by the hands, and that
human vibration, hand-arm vibration comes and to the body and creates the problem in the human being. Then the workplace well-being. So whether the workplace which is designed, okay, that is having any problem in the design or with the some parameters that can be considered for the overall improvement. So this part. Then this is the about the future. Okay. So now with this brief introduction about how this particular topic has been evolved, now let's move on to the topic ergonomics. So this ergonomics, those who are new, for them, so ergonomics is basically the word which has been derived from the Greek, okay, made of the two words, ergon and nomos, which means the study or the law of the human. Okay, so human study, human laws that we are studying, keeping the human being in the center. Okay, this diagram which is showing you the different application areas or different area workplaces where the ergonomics is can be applied or people are still using. Okay, some areas are already overbitten, some are untouched. Untouched saying is a bit wrong because nowadays no area is actually untouched. Maybe we can say that very few have already attempted that particular areas. Okay, so ergonomics basically what we are doing, so it is a study of the interaction, as I told. So it is not about the machine, or it is not about the completely about the human being, but it is about the interactions. Okay, so whatever be the systems are with which we are not like all the systems we are not directly interacting, we are interacting with the interfaces. Okay, so we are involved or we are basically focused about that interactions. So and we have to take care of the user difficulty, because if you are interacting, then this parameter can be there, and that is going to have some adverse effect on that performance. Okay, if the interaction is not good, then what will happen? The efficiency will decrease. Okay, as in my introductory speech, I was talking about this design of this projector screen. Okay, so screen part is fine. So as we discussed on that, so we are taking the utmost care while we are designing as an engineer. Okay, something, the product which we are designing. So there is absolutely no flaw in the from the engineering aspect of this particular system, because it's, let's say that it is a motorized screen. Okay, motorized screen means it should properly go down, go up, okay, or wherever I want, it should be stopped. Okay, so that part is functioning well, but because they have not keeping in mind the cognitive load which is going to be have in the human being, so what they have done, a simple mistake they have made. The connection they have given from this side, okay, but how they have connected here. So although it is not going to affect much, but it is a design flaw. Okay, from the function point of view, there is no drawback in the function, right? If I will click the upper side, it is going to up, lower one it is going down, mid one it is going to stop. Every function from functionality point of view is very good, but these are the design flaws. When initially it was not hanged like this. Okay, so because this wire is coming this side, this wire is coming to the power point, power plug, so it was in the opposite direction. In the opposite direction, what was there? This is up, this is down, just the reverse case. When we are pressing this one, it was going up. Okay, sorry, so it was up, so it was going down. Then we reversed it, then we saw, okay, this is the correct positioning of for installing it. Okay, so we took some time, although this is not the matter of anyone's life. So okay, we can adjust here the flaws, but what about the other critical zones? Okay, let's say that the air traffic control, whether you will get this much time to analyze if some design flaw is there, right? Then because there is the decisions which you have to take in fractions. Okay, so how that, although we are taking the utmost care from the design engineering aspects, but design plays an important role, correct? And that basically leads to the cognitive loading on the human being. Okay, the interactions which we are talking about. Okay. Now when we are talking about the systems, so there must be some parameters. If we are considering that, and with the analyzing that parameters, we can improve the overall system. So these are some 3 parameters: changing the interface, user interface, changing the work environment, and changing the changing the task. Okay. So what basically the user interface is? Okay. User interface means the what I was just now talking about, the interface with which we are interacting. Okay. And it depends upon the type of the product that you are designing, and in that you want to do the modification. Okay. Sometimes one particular product which we are designing, which changes the interfaces within that particular product itself. Okay. And we have to change, or what if you want to make the changes, so we have to make the changes in that itself. Sometimes the interface is somewhat remote. Okay. The same thing like the remote control. Okay. So maybe then the knob which we regulators for operating the speed of the fan. So that is one particular interaction. For that, the another function is the remote control. Okay. So how this has been designed? So it is not necessary that if I want to operate with one particular equipment, let's say that fan is equipment, and I am interacting with the knob which is on the wall, or I am interacting with the remote control. So so always it is not necessary that the product itself will be having its interaction on its own. Okay. It may be the 2-part component where we have to modify the interactions. So you have to think what parameter you are going to consider. Then changing the work environment. So environment plays an important role. In which particular environment you are performing that particular task. Environmental parameter means the temperature, humidity, the lighting arrangements, okay, and the noise pollution. So these all things under the category of the work environment. If the work environment is noisy, then you may not able to give your attention. Okay, like when you were discussing about the cognitive, so there also some parameters were discussed about the attention, right? So attention, so there are different types of attentions are selective attention, divided attention, okay, sustained attention, focused attention. So what basically the attention is? Attention means how much importance you are giving to the information which is coming to you. Okay. And that again depends upon that what has been discussed, the fuel and the filter. Correct. So these are the environment. In the same way, the lighting conditions. Okay. So if you are writing something or you are performing something, let's say that you are typing, okay, and the visibility is low at that particular location in the system level, okay, or in overall the environmental level. Okay. If I will focus too much of light here on the screen, then maybe you will be facing the difficulty in visualizing the content which is at present projecting in front of you. Okay. So like some vehicles coming in front of us and with a high glare on the headlight, and we are unable to view what actually the beside of that particular vehicle is. We are completely blind for a moment. So something like that. So what about the lighting effect? In the same way, the task to make the compatible with the user characteristics. User characteristics means the end result can be obtained with the multiple ways. Let's say that I want a result. Okay, I want a result, some X results I want, and it is not necessary that X result can be obtained by a particular method only. It can be obtained maybe the multiple. Let's say that if I will take the example, like when we are learning the coding language, any language. So that time what we in very basic class, we just start drawing that star, that half triangle star, right? The matrix, that upper half or the lower half, the triangle. So whether that we can generate that, let's say that that is the end result. So that end result, whether we can draw in C only, it's not necessary. We can use the C++ also for obtaining the same results, or somebody who are expert in the MATLAB, they can also write some code to obtain the result. That means if my end result is known, So based on that, it is not कि I bond you to do this particular algorithm or this particular set of skill you should have. And based on this only, the two different concept of the ergonomics, that is called the fitting man to the job and fitting job to the man, the two concepts. Those who are aware about the ergonomics, they must be knowing fitting job to the man and fitting man to the job, what it is. Okay, so that is the user characteristics we have to give importance, and according to that we can modify it. So this is about the system improvement. Now if we will not improve that system, then what will happen? Okay, so what are the factors that are going to be affected, or by implementing this what we can overcome? So inefficiency, fatigue, accident, injuries, these are the parameters which are always unavoidable. Okay, not always unavoidable, but unavoidable and uncontrollable. Okay, from the owner of any company point of view, okay, or organization point of view, you do not want that your employee should get any kind of the inefficient performance, give inefficient performance, or met with some kind of the fatigue or injury. So you don't want this. These are the which you do not want in your system. Okay, so you have to remove it, and this you can remove by the upper parameters which is listed. Okay, so these are the things you have to taken care. Now this basic, very basic, you can find out in any book, the classification. Okay, so ergonomics basically classified into three groups: the physical ergonomics, cognitive ergonomics, and the organizational ergonomics. Cognitive ergonomics you have already discussed much in the lecture, so leaving about that. The physical ergonomics. Physical ergonomics means the activity which you are performing, basically the postures, okay, the biomechanics, okay, or the activity which requires the physical. Okay, so that category of the work. Okay, if examples I will say, so in a day-to-day life, the different service providers help we take. Okay, let's say that I am using the, from the student point of view, every day the students are using what? Bicycle. Okay, like most of the campus, like IITs, whether it is IIT or NIT, so they restrict their student to use the bike. Okay, most of one is using the bicycles. Bicycle gets puncture also, right? So what you do? What you go to the puncture shop? What the puncture repairing person does? Okay, how they sit? Okay, that posture analysis you can make in a physical ergonomics. Okay, so if they are sitting at a particular lower level, the ground level, or you must have seen they are using a seat of the older cycle, they take out, okay, and they are using to sit on that. Why they are sitting on that? So that they are maintaining a particular posture which is basically reducing their MSDs. MSD is nothing but in general, in the layman words we can say the pain, okay, pain in a body, with over the period of the time that takes the form as the MSD, musculoskeletal disorder. Okay? Okay. So the relevant topics which you can consider in this physical ergonomics is the working posture, the material handling, the work-related musculoskeletal disorders, or the workplace layout. So these are the things or parameters which you can study. Cognitive, just I am skipping. Okay, so already you have discussed much about this. Only one thing I want to say, like the whatever the mental activity for those who are from that CS background or EC background. Okay, so you are basically developing the different types of code or the websites or the applications. Okay, so with utmost care you are designing and it is giving the best result. Okay, but whether have you thought about that to reach at the particular output, how many clicks you are making in that? Okay, so that clicks, number of clicks which you are making to get the desired output, that is the part you should consider from the cognitive ergonomics point of view. As many clicks is required to reach the output, it is increasing the cognitive load on the human body. Correct? So as an engineer, we design, our objective is this, and we are designing, we are running the code, and it is working perfectly. but what about the number of clicks which is required to obtain that particular result? Okay. So that are the parameters which the human interventions are required, and that is leading to the MSDs, or not MSD, the cognitive load it is increasing. Organizational ergonomics is more related to the that managerial kind of thing. So basically the team management, time management, crew management. So these are the parameters which basically performed in this organizational ergonomics, the optimization of that. So in ergonomics, what basically the work systems are. So in that ergonomics, the basic work system. So whatever be the work system is there, so that comprises of the three components or three elements. Okay. So one is the man who is performing, or who is the operator, with whom it is operating, that is the machine, and where it is being operated, that is the environment. So these are the three parameters: man, machine, environment, because every activity is going to be under the environment. So these are the three parameters or three elements which is interacting with each other. Right. Now here, but if you see, there are not the direction, not the interaction is written, but it is written the directional interaction is written. Okay. So interaction means A is interacting with B, B is interacting with C. So there will be only 3 interactions, but because it is the direction interaction, it is the 6 interactions. Okay. That means man is interacting with the machine, machine is interacting with the man. Two-way, like the positive X and the negative X, in the same way, man to machine and machine to man. 2 ways. Okay. Now what basically we are analyzing here? The dominance of one with the other. Okay. We are using a greater than sign here for the showing the or representing the interaction. So man, so human, H is represented by the human. So human greater than sign the M, machine. That means the human being is dominating the machine. There may be different applications where human being is basically dominating the machines. Can you name anyone? Anything where the human being is dominating the machines? Or always machines dominate the human being? Sorry? Vehicle. What vehicle?
Sir, in a autonomous vehicle, we can take over the control at any moment. That time human is dominating the machine.
Not that actually. Okay. So basically the human is controlling the machine. Okay. Or dominated, human is dominating the machine. That means with the excessive amount of the force or the pressure, that can dysfunction the functioning of the machines. Okay. Here when we are talking about the man-machine interaction, so it is not the hardcore machines with which you are basically interacting. So here the any simple product can also be your machine, okay, with which you are interacting. Okay, the pen or pencil which you are interacting, so that could also be your machine, okay, for this interaction analysis. Okay, you have to think the diameter of that, how that has been designed. Okay, if you will increase the diameter of the pen or pencil, then what will happen? Whether with the same efficiency you can write, let's say that I have given you task to write a paragraph. Okay, 1 page I am asking you to write. Okay, how much time you are taking when the diameter of a pen is or pencil is less? If I keep on increasing, then what will happen? Okay, the shape which is given, if it is circular in nature, the steps is given on that. So if we are putting, then what changes is there? Correct. So here, let's say that any kind of sensors, the piezo sensors specifically. Okay, if you will apply the excessive amount of force in that, so it will dysfunction. Similarly, the temperature sensors. Okay, if you will apply the forces, it will dysfunction. It will not function properly. Okay, so excessive amount of force performed by the human being is dysfunctioning the machines. Other way where the machine is having the adverse effect to the human being. So you take any example of the vibrating machines. If continuous vibration is there, let's say the drill machine which I quoted just now. So you keep on that particular activity, definitely you will be having the different kind of MSDs, right? Working on the stone polishing, right? Yes. So that is the case. So stone polishing is one activity, or stone crushing is activity or the job where a continuous vibration comes to the hands, and that generates the hand arm vibrations that we call. Okay? So there it is affecting, so machine is dominating the human being. In the same way the others can be analyzed. There are parameters where human is affecting the environment, environment is affecting the human being. That means with the change in the environmental conditions, the performance of the human being decreased. Let's say the extreme cold temperature if you are working, or extreme high temperature you are working. Definitely you know, you must have experienced. In winters, okay, very cold places if you will go, you just try to hold something. You will feel ki you are not holded, means you have not hold anything. Correct? That sensation gone. It goes, right? So have you ever experienced that? So that is the effect of the, because if let's say that at that particular moment you have to perform some precise activity, you have to rotate some knob that is basically regulating the temperature of, let's say, that some power plants. Then what will happen? You are not having the senses, that means you might have applied the more rotation. Later on you are able to see, okay, that I have moved the knob too much, okay, as beyond its requirement. By that time anything can happen. Correct? So these are the different effect of one over the others. That's why we are calling it as the directional interactions. So one parameter is affecting or dominating the other one. So these are the basically 6 1. So it is listed here. You can just human is dominating the machine, sorry, yes. Then human being is dominating the environment, machine is dominating the machine is dominating the human being, machine is dominating environment, environment is dominating, so and other things. Okay? Now let's say that system improvement we have seen. Okay. Now you are giving the recommendations or suggestions. Then how to apply that particular suggestions or recommendation, and when to apply that particular suggestion. Whether there is any criteria on the selection of that particular recommendations. So there are, again, these are the 5 different criteria or ways of prioritizing the recommendations. How you give the priority to the given recommendations. So first one is the implement the recommendation immediately. Let's say that I have given some recommendation for some improvement. Whether you want to do that immediately, whether you can avoid and say that okay, I will do after some time. So there are some situations are there. So it is a situation based, where the human life or the high economic is involved, so that we say or think that we have to do it as soon as possible. Okay. So these are the things. So where the serious design flaws are there, that is threatening the employee's life or the health or overall the system reliability, that time we say that we should immediately change that one. Immediately change and recommendation soon means there is some difference. Immediately means right now I want to do this. Okay. Let's say that the brake on your vehicle is not working. So whether you can take chance of driving your vehicle without brake, you cannot take chance, because anything can happen. Okay. But only that shoe brake, if it is worn out little bit or one side, okay, or the clutch plate is worn a little bit, then you can say, like the periodic maintenance which we do. So that can be avoided. So similar kind of recommendations, if they are in a system, so we have to first identify and analyze that what is its adverse effect on the system overall or on the human being. Then based on that we try to give the importance to that, and we try to implement the equipment when it is shut down. Sometimes the implementation which we are receiving, so it is for that or to apply that particular recommendation, we have to switch off or shut down the system. But the system switching off or shutting down is too costly to the, maybe the industry persons can better correlate it. So it is not easy to switch off or shut down a particular machine, okay, until unless it is highly important, because that gives the because if it stops in between, then it is going to lead the high economical loss or production loss. So we cannot avoid that one. So what we do, if it is the extent which it is to which it is possible, okay, we run that, and the schedule shutdown is required at that particular moment, the suggestions are implemented. So this is the one. Implement when cost benefit is acceptable. Okay, so this is again profit win situation. Okay, you keep on avoiding the things, and when this cost benefit is equivalent, that time you are proposing, okay, now I can changes or I can implement this particular recommendations. Implement when equipment is built or purchased, right? Let's say that in your house one particular light is not working, then what you will do? You can if there are multiple that facilities are there, you can avoid, okay, and whenever you will buy the new one, that time you will install. So similar kind of things are there. So these things you have to consider and correlate in the form of the human being interactions, system interactions. So with this recommendation, what basically the objectives of the ergonomics is? So we have to build the equipment which are usable and safe. That means I do not want to develop a particular product which cannot be used by the person. Okay? If I am developing something, then it should be usable and it should be safe. Okay? I do not want, by using my developed product, the user get hurt. Okay? So earlier we saw then inefficiency or injury, tasks that are compatible with the people's expectation, limitations and training. Okay, that means the intended purpose for which a particular product has been designed. Okay, so that expectation should be fulfilled by the developed product, correct? An environment is comfortable and so these things you can go on. Okay, so as some case study you want, so here one particular case study I have kept for your just knowledge, the how this ergonomics. So this the brief I shown you. Now this is one particular application area. Okay, so biomechanical modeling and biodynamic response analysis of the seated occupant under the whole body vibration. So what basically the whole body vibration? So there are basically in the at workplaces there are two different categories of vibrations we consider in a basically the physical ergonomics. So hand arm vibration means vibration coming through the hand. Whole arm whole body vibration means the vibration which is coming maybe the multiple places or the interactions with the machine, and it is going throughout your body. Okay, so that is called the whole body vibration. So this is the human skeleton and the different zones are there, and what are the whole body vibration associated disorders are there. So that has been listed. Okay, so I think is it true, right? So we are having the doctor with us, so he can verify whether this many disorders actually a human being experiences or not. Yes. Okay, so this is from the literature. If whole body vibrations is encountered or experienced by the human being, so this many. So every body or segment is having its own natural frequency. All of you must be aware about the natural frequency when a particular frequency is matching with the system frequency. Okay, or what the resonance is. The resonance is, so when it is matching, so that time it is the amplitude of the that vibration is more. Okay, so that thing, and basically the low frequency vibration, okay, that is basically affects the human being too much, specifically below the 8 hertz frequency. So most of the body parts excites or reach in that unstable zone. So the lower frequency range we should try to avoid while we are developing some machines which is basically vibrating. Okay. So in this basically biomechanical modeling and biodynamic responses. So biodynamic responses is basically described with these three parameters. What is written ST. Okay, that means the seat to head transmittability. Human body, the mechanical system of the human body, like any system which is vibrating, so it's having, let's say, that mass, stiffness and damping. These are the three parameters upon which the natural frequency depends. So same way the human body is there. So we are having the blood, okay, we are having the bones, we are having the muscles. So this we are basically try to model in these three parameters only: mass, stiffness and damping. And that while modeling that, it has been this experimental results, it says. So human body, this parts basically at 4, 5, 6 hertz, most of the parts start exciting. So three parameters are basically analyzed in the biodynamic responses. One is that ST, that is the seat to head transmissibility. Another one is the DPMI, that is the driving point mechanical impedance, and the third one is the AP, that is the apparent mass. Okay. So what basically the seat to head transmissibility is? This is the ratio of the acceleration signal which is observed at the head location to the input location. Okay? Head is basically output. Doubt? No. So let's say that somebody is sitting and you are using some, let's say that basically for whole body vibration we use one particular system that we call the seat pad accelerometer. Okay, so seat pad accelerometer is seat pad, its name it's suggesting. Seat pad means on the pad you are keeping. So it is some circular in nature that associated with the triaxial accelerometer, it will give some signals which is passing through your back or buttock. Okay, then you using some fixtures, you can like that is called the bite bar. Okay, so that you keep and you just measure that. So how much is transferred from your buttock to the head. So in that way you are basically trying to calculate this one, acceleration signals. In the same way the DP, so only the parameters which we are considering is change: acceleration, force velocity and force acceleration. That is the different parameters which we are considering into the analysis. Okay. So this is the one work which is done by one of the PhD student. So what was basically the motivation and why we are trying to analyze that one? So these are some list of the motivations. So human body is the most sophisticated structure in understanding, as the inaugural session also our director has told. Okay. So this is the most sophisticated structure, human being. Okay. So or human body behavior. So under the vibration environment is the primary concern basically for the automobile industry. The mannequin which is being designed, okay, for the crush test analysis. So for that crush test analysis, basically the mannequin which is designed, so for them the biomechanical modeling is very important, how you are modeling. So it should actually replicate the human structure. Okay. So right now what I have shown is the lumped parameter modeling. Okay. So another slide is there. So it will show that what basically the lumped parameter is. Lumped parameter is nothing but the mass, stiffness and damping, which I just now I was telling. So in the same way we are dividing or segregating it. Okay. So this I think motivation you can skip it. So just this is the modeling. Okay. So as the seated occupant, so there can be like different positions you can consider. Okay, and what amount of vibration and from where it is coming that you are interested in. Okay, so this is the first phase of the work which I am just keeping in front of you, where only the half body is considered. So from the trunk to the head, okay, including both eyes. Even the legs are not included in this, okay, and the hands are not included in this. Only this trunk position up to this head, because a person is sitting in this chair, so how that vibration is passing on, and that has been calculated. So this was the first work. Say in the second work, we extended this work and we included the leg portion. So we took the both input from the leg also, then actual driving position. In actual driving position, the steering will be on the hand. Okay. One more thing, that in this particular thing we have not considered the backrest, but the driver will be having the backrest also, and backrest there will be some angles. So that angle, again there will be some springs we have to connect, how much the distance the connection we want to provide. Okay. Then the steering the person is holding, so that the hand will be modeled in the same fashion. So this is the left side one, is the segmented representation in terms of the mass spring and damping. The right side is nothing but showing the free body diagram, where by using the any method, maybe here the Newton's second law is used, F is equal to ma you have to do, and you have to obtain the final equation of motion. Then you can apply the optimization technique, you can apply the constraint equations, what are your constraints, and based on that any of the optimization technique you can, whichever you feel better, that you can apply for this particular analysis, which the table is shown here. So for that we have applied the Firefly algorithm. Okay. So the with Firefly algorithm and without Firefly algorithm. So without Firefly means the other whatever the algorithm which has been used, optimization technique has been used, and there are some literatures. So 2 degree of freedom, 4 degree of freedom, 8 degree, 7 degree of freedom. So that we have compared with this, developed a 10 degree of freedom model. So this is the again one case study on the postural analysis. So this is the work which is done by the master students here. So most of the universities, okay. So roti making or roti is the part of our dish. Okay, without that our meals are not complete. Correct. Whether in the most of the area, even in the breakfast, people prefer rotis or paratha in other form we can say. Definitely in the lunch and the dinner. Okay. So roti is an important part of our meal. So what about the workers who are involved in a mess kitchen? Okay. So here what we have done, so we just segregated this particular activity in four stages. One is the neutral position, another one is the starting of the roti making, that is the dough preparation. Okay. So dough preparation, then the second one is the what we call that rolling, that one. Okay. And the third one is the baking. Okay. So these are the four stages that basically completes the roti making process. And in these 4 stages, what are the positions that the workers are occupying, that is basically analyzed. Okay. These are the visuals that has been imported to calculate the different joint angles. Those are familiar with this ergonomics, they know there are 2 different techniques. One is called the REBA and another is called the RULA. So REBA is nothing but the rapid entire body assessment. RULA is the rapid upper limb assessment. Okay. Rapid upper limb assessment. Upper limb is above the trunk we are analyzing. Entire body means entire body we are assessing. So in that we are calculating the angles of the different joints. And based on that particular joints, we are reaching up to a particular score. And based on that score, we are saying that if this particular positions can be dangerous, or it can be the position in which you can continue your working. Okay. So the slight changes in the position, you can overcome the MSG. So these are again the work which is being done, and later on the same model is incorporated in this CATIA model. Mannequin is prepared, then the Ergomaster is one software that has been used, and the same thing which is being done manually is calculated and verified the results. So this is the second case study of the physical ergonomics. So same thing like the material handling activity who are involved, okay, in the production side. So the similar kind of activity can be analyzed. Okay. Another one work is there which I have not shown here. So that is nothing but the use of like computer science or computer vision. Okay. So Rebarula, so that work actually is under preparation, I can say. So by clicking the multiple images, instead of identifying the Reba and Rula score manually, we can whether we can get that automatic with the help of computer vision. Okay. So that also we have done, but here I have not presented that one. Okay. So these are the two case studies that I want to show you. Okay. So this could be the, you can say, the assignment, or is up to you. Okay. But these are the three different directions in which you can perform the activity, like select any repetitive task, that means the any industry or the lab settings, any kind of lab settings where the repetitive task is performing. Yes, physics. Any work in which a repetition of the work is required, something keeping from one place to another place. Yes. So in the lab setting it can be done. So what basically you have to record, or what you can do. So these are the things like number of repetitions per hour, then the duration of that continuous work, then the force that is applied to perform that particular task. So these are the some primary parameters that you can calculate, record, and based on that some analysis can be done. In the same way, related to the hand arm vibration, so again these are different areas of the physical ergonomics. Okay. So hand arm vibration, so identify any tool or machine which is basically generating the vibration, specifically the hand arm vibration, maybe the, as I told, the grinder or the drilling machine. This could be one. And what you have to observe in that, so duration of the exposure, how much a particular person is exposed to that particular task, because it is not like if I am doing a drilling operation in my home, so I think once in a year or twice in a year I am doing. But what about those who are in the profession of that only? So they are for extended period of the time, maybe for continuous 8 hours or 8-hour shift they are having. So for that, okay, so what is the vibration, those values are there, so that you can calculate in this. So grip and posture, so what is the gripping position that gripping they are getting or not, so that kind of analysis you can do. Then lifting and material handling observations, so in this again this particular parameters can be studied and identified. Okay, thank you. If you have any doubt, please. Yes, please.
How can we differentiate good postures and bad postures?
Good posture and bad posture. So the posture in which you are feeling discomfort, that is giving you pain, okay, because in layman words we say pain, okay, but later on that in a scientific term we call that the MS, musculoskeletal disorders. So again, whether it can be in your muscle, it can be your tendon, it can be in your ligament, okay. So nerve system, like continuous holding like this in the contact surface, okay. So because of this is in static contact, okay, compression, and you will feel discomfort. How you should maintain while you are keying? So it is the neutral position of the wrist. If you are performing in this neutral position straight, then you are not going to feel any kind of the MSDs or pain. But once you are tilting it, okay, like the roti making I shown, okay, there by holding that you have to flip it. Flipping means continuous twisting is required of the wrist. So that is basically giving you the MSDs. So if you are doing that for maybe a couple of times in a day, it's fine. But think about the hostile strength which is having the 500 or 1000 numbers. And for them, at least for if 2 chapatis they want to make for each, so they have to make 2000, okay, and for that the flipping continuously. So and that is not the one time, morning for the lunch, then for the dinner, and this keep on every day. So that basically generates the MSD. It's not key one day it will generate, long over the period of the time it shows. Anyone? Yes, you have. Oh, stretching. Stretching is one of the exercise to remove the exertion. ठीक है? So there are different recommendations are there to remove this repetitive strain injuries. So stretching is one, taking rest is another one. ठीक है? Movement, which generally we do at our workplace after sitting for a specific period of the time, we should at least stand and we should stretch our body, we should walk. That basically reduces the chance of getting MSD. That the similar way, like continuously staring the screen, that creates the strain on our eyes. Okay, so just for a 5 minutes or the 2 minutes, if you will close your eyes, okay, so that will stop that strain, and again with the full efficiency you can start working.
Ergonomics of posting. Like you measure how long a person can make the dough continuously once again.
Yes.
So that you would have taken multiple times.
Multiple times we took, multiple like many times we went there. ठीक है? Those who are involved are regular in that, and apart from that, like in MES, it is not a specified task. They are involved in this only, is not so. So they are like, this is the end part of their like work, I can say. Okay, before that also they are involved in some other activity, let's say chopping and cutting activities. Somebody is involved in the washing the utensils and other thing. So they, how much time they are spending there, how much time they are spending in this, and those who are only called for this only, like there are some category of the workers who are associated with this only, they are not performing other tasks. Some are other activities also. Then how much the variation is there. So that part is basically analyzed.
Like there are multiple interruptions. So how do we know a person is getting fatigued at this point if there is no interruption? That how?
No, fatigue we have not calculated in this. So we have calculated that in this particular postures which they are occupying, whether in that particular posture they are how much score they are getting. Okay, and according to this, the scores which I told, Reba and Rula, so that falls under which category? So there are some ranges are there. So let's say that 0 to 3 adjustable, then 3 to 5 means some modification is there, and some modification in the posture is there, then again it can lower down your total score. So in that particular case is okay. The postures which you are maintaining to carry out that work is safe. That actually we want to say. Like sometimes like the short-heighted people, okay, and the platform height is too much, so they have to put extra effort, maybe extra bending or stretching is there. And if you are just providing a table, okay, like you might have seen the jugaad, okay, somebody is standing on the that bricks or stone. So what basically they are doing? So that is nothing but they are trying to improve their posture. Okay, in layman words we say that they are doing some jugaad, right? But it is actually scientifically, if you will go, that is nothing but they are trying to improvise their posture so that they are not feeling the discomfort. Okay. Anything else? Okay. Done? Okay, thank you. We'll meet tomorrow. It's good. You can spend some time over there.
Yes, so there is a daily flight here from here also, from this town to Bhubaneswar. Daily flight, no?
Yeah, daily flight. There is a flight.
Oh, really? From this town?
Yes. Bhubaneswar, that place.
So Bhubaneswar, the capital of Odisha, that is just 1.5 hour distance from Puri. So there you can travel and.
Actually, one has to stay at Bhubaneswar. Puri also we can stay, but taking flight then it will be easy to stay in Bhubaneswar, then go to Puri, then come back to Bhubaneswar, and then take the flight.
Okay. Oh, is there any Vande Bharat train from Bhubaneswar to Puri?
So I think you are not met with him.
Yeah, hello, I'm Abhinav. I've just joined.
Okay.
So yeah, this is a new experience for me as well, and I'm exploring the campus as of now.
So he is like you only. He is also new to campus and new department.
Yeah.
So recently he joined.
Say it again.
He joined recently, few days.
Oh,
few
yeah,
It
yeah.
has been just 15 days.
Oh, wow.
So
Okay.
he's basically all of the new faculties who recently joined.
Okay. That's great.
So the first day I arrived here, I went to Puri after the interview.
Ah.
Yeah, that is the best place.
Okay.
I think you should also plan accordingly.
Okay.
Yeah.
I still need to explore other places here in Odisha.
Hmm.
You met with him, no? Right? So,
Yeah, briefly, yeah.
day one. You met with him?
Yeah, some.
Okay.
We had little talk.
Yeah, a little bit, right. And are you all mechanical engineering background or some design?
No, I did my PhD in design. I actually did my master's in design and then extended my master's thesis in PhD. So I've done my PhD in design, port design. So my area of research was I was more into extreme user categories and trying to incorporate those user categories as mainstream user categories. Extreme user categories, as you might have a knowledge about, are those categories who have specific requirements from an interface.
Like,
So
with disabilities?
Not yes, they can be disabled. I mean, they have such kind of requirements. Other than that, they could also be someone who has some specific kind of whose requirements are different from mainstream users, like left-handers, for example. So you can consider them as extreme users, or even colorblинds. So there's no difficulty in day-to-day basis, but they have some specific requirements from the products or interface that they use.
Makes sense. Good. Yeah, I'm left-handed, and I remember when I was 10 or 12, my father bought me left-handed scissors. He said, "Oh, these will help you." And I'm like, "What?" I mean, I didn't really make a big deal out of it, but I've had a number of left-handed tools. Left-handed knives, so I do have a left-handed knife for cutting the fruits and vegetables.
So what hand do you use your computer mouse with?
Oh, I'm still right-handed mouse.
Okay.
Yeah.
So did you ever were you ever curious about using the computer mouse?
You could set it, but I'm like, I'm already doing this. I don't know. I don't think I learned that till I had been mousing for a long time.
So when you're using some product with left hand, which is designed for the right-handed, you feel difficulty?
Oh.
Like most of the products are designed for.
I don't think it's a big deal for me. I think I just use my right hand. Maybe my right hand has been trained enough to do things okay.
It's something which you want to use with left.
But like I play guitar with the right hand, so I can play normal
Basically,
guitars.
you are ambidextrous.
I guess so. Yeah.
Most of the left-handers are actually, because they have to adapt to so many things that they get accustomed to.
I was surprised on the knives. Do you know why there are left-handed knives? I mean, it's because the blade of the knife is like this, or it's actually, I guess it's like this. So when you cut, if I use a left hand on a normal knife, my cut is going to go slanted. So if I get a left-handed knife, it goes straight down. I don't know. It's minor. I don't feel discriminated against.
But still, I recently went through a few products who are very keen about this left-hand and right-hand. Although there are low number of people or the users belongs. There is one company called Wacom. So
Wacom.
we have
Like
one
the
drawing
tablet.
tablets.
Yeah, the Wacom tablets,
So
yeah.
earlier Wacom used to come with buttons on this left hand. So you can draw with the right hand. Whatever the click you have to do, either zoom in, zoom out, or whatever, it will be on the right hand. Left hand. This year they have launched one product. So interface is something like that, and the buttons are on the top.
Oh, nice.
So no matter which hand you are using for the drawing and which hand you are using for the buttons, it is for both.
It's actually a lot many things are happening in accordance with accessibility these days. So I mean, designers are trying incorporating other different types of user categories in their products or interface. So things are becoming universal. They are considering things in a lot. I mean, from accessibility point of view, they are considering a lot many options to provide affordance to the users.
Great.
So India is a big market basically. India is a big market.
Yeah.
Yeah. And we have a variety of people also. So the studies again, we are combining design into the people's mind. We are trying to get into it. Now you can see in terms of any product or service, we are improving our design research.
And you've got, India is the most populous country now?
Yes.
I think it's yeah. So you've got far more users than the US. So maybe you're ahead of things on that. Yeah. There was an effort for a while to talk about design for the other 90%, where the idea was that most of the product design, like from Apple and others, was for the richest 10% of the people. And so they said we need to do design for the other 90%. And it was, ranging from all sorts of household products to products for poor people and water purification, things like that. So there's been a growing movement for this.
And majority of the company, I think right now, this Microsoft, Google, Apple, they are also putting lot of effort. And there is term we call new billion user. New billion users.
Oh.
So since whatever the new technology come, the most privileged user are the ones who get used to it. And the population who are left behind also over the period of time adapting to that technology. So how to make that technology also accessible for the person who are coming for first time?
Yeah, that's
so
right.
So Google and Apple are doing tremendous job in this. Maybe in terms of culture, maybe in terms of language, maybe in terms of the pattern they use or the literacy level they have, and how to make it compatible with that.
Yeah. I spent a little bit of time in the class showing the students a blind user using a phone.
Yes.
It's fascinating because they have it talking really fast because your brain can understand like 3x talking, and the screen's not on, so you save batteries. But they're just like they're typing like this sometimes. Anyways, it's good. There are all these features our phones have hidden for this.
Accessibility feature.
Yeah.
Even while booting the Mac for the first time, they will show the accessibility feature. In Windows, you will not be getting the accessibility feature to adjust. But in Mac, on the first time booting, they will show the accessibility feature. They are so care about the user.
Yeah, that's nice. So are you the only design or other people design?
So I also done my PhD in product design.
Okay.
So I focused towards ergonomics part of muscle fatigue for a disabled person. So I was designing a wheelchair.
Oh,
so
nice.
That was my PhD problem. After that, also I have been an entrepreneur. So I have developed some medical devices in field of gynecology, pose estimation. Right now, my startup is working on detecting these neurosignals. So we are trying to make that device of detection of this EEG signals with as much compact space as we can. So right now the problem is, I have seen your photo where right now the devices, although they have reduced the number of wires and all those things, but still there is a scope. So we are trying to solve that problem.
Yeah, I've seen the Mindwear with the 9 sensors or something like that. That doesn't do very much for you, does it?
So what we are planning to do is we are planning to reach up to 128 electrode points.
Wow. And not have a whole hat?
And yes. So we are trying to reduce the amount of space that it will cover. So obviously dry electrodes.
Yeah.
At the same time, we are trying to reduce the processing chip also.
Okay.
So I work in embedded of that and also the usability part.
So that hat you saw in the picture, I showed it wearing this. It was brand new, it's 3D printed, dry electrodes, and it had, I think, 64 or something like that. And it was $20,000.
Yes.
So we spent all that US money for that. And on campus, there was a woman who's expert in EEG, and she has a whole lab with the wet electrodes and the standard EEG. So we're just like, oh, you should try this because it says the cap, you can wear it and walk around, and that's unusual. and she tried it and said, this is not very good. So I was like, I just spent $20,000 and the cap wasn't very good. But so maybe yours will be better.
So we have to look for this baseline and everything. And the most important part is impedance. So the most innovative thing that startups in US are doing is reducing the impedance, which means that although you are wearing a cap, but the maximum amount of voltage detection should be there. The thing is, whenever you are using your wet electrodes, obviously the amount of impedance is low, and so that you can have higher detection rate. So if somebody cracks that part, then obviously we can have portable devices. Just like I wear a cap and you cannot see any electrodes, any wires, anything, you can just transfer signals through a Bluetooth on your phone.
That'd be
So
great.
we're trying that.
That'd be great. Huh. Yeah, I know there's a lot of people interested in EEG if you can get it right.
Yes, sir. So a lot of stigma is also attached. So the problem statement was given by some professor from UIUC. So Harshal Mahajan is there. So what he told is, obviously, so the device is for older people. So suppose if I want to detect an artifact related to, let's say, some kind of disease that is going to occur in later part of their life. So if I want to put this cap for a longer time, so there might be some kind of stigma. People will look at him like a test subject kind of thing.
Yeah.
So we want to reduce that stigma. That okay, it is just a cap I'm wearing, and can I have a live detection or recording for larger number of hours while they are doing all these activities or daily living.
At Iowa State, there's a dean. He's called the dean of the graduate college, so he makes all the rules for graduate students and what you have to do to get your PhD or master's. And he's very stern. There's no smiling. You know, he's just very stern all the time, and he makes rules and he keeps the rules. And then he had a brain tumor, and so he had to go through some surgery, and it was pretty significant. And now he wears this odd thing on his head that's like, there's still like a hole in his head, right? And there's like a tube that comes down his, shoulder into this gadget that sits on the desk in front of you. So my colleagues and I feel like he was already sort of stern and unpleasant, and now he's just scary. Like now he's like a science fiction monster or something like that. And so if you had a better system, right, it would be great.
But sir, I think that tube is related to after this operation, there might be some blood clots. So they provide a tube so that it keep collecting blood until all this hemorrhoid blood is get stored.
Yeah.
So I think that was the case.
Okay.
That might be the case.
I'm sure.
Discharging the waste.
So it takes time. It takes 10 days, 15 days. So that might be the case.
Yeah. But I'm sure he would appreciate if there were no stigma.
But eventually there is a big market in medical devices for detecting all type of physiological signals like EMG, EEG, anything.
Yeah.
And if the thing is, you have to make it more and more portable.
Right.
Like we have a lot of features right now on our watch, like ECG detection is there.
Mm-hmm. Some of my colleagues use conductive ink, and I don't know if there's a popular thing here. The kids in the US will do temporary tattoos. Like it's like water-based, so you get a little, it looks like a sticker, and you wet it, and then it looks like you have a tattoo. And so they're using that technology, but with conductive ink, so you can stick on this temporary tattoo, but it's a sensor.
Okay.
So it's measuring something about your skin, and then it'll talk to your phone. So I was like, oh, that's interesting.
We have a dedicated biomedical and bioengineering department.
Okay.
And there are people who are working on development of sensors and for the healing of the cuts and all those things. So we have people
That's
who are
nice.
working in these domains.
And you would think as soon as they have some new invention, it's going to need your help to understand how to work with
In
drugs.
at your place, what are the new thrust research areas which are going on?
The top research areas. So we have a new biomedical engineering degree. So that's a new one, and we are feeling behind that we just got ours going, and the other places we're getting it going.
So in cognitive things.
Yeah.
Anything which is recent work which you're doing?
Just me. I can do just me. I do a lot with cyber sickness. So if I put on a VR headset or an AR headset, there's a large percentage of people who will feel nauseous after a while. And so we're trying to figure out if we can help them adapt so they won't feel nauseous. So our big success more recently was that we had a 3-day training program. So there was a game that makes most people nauseous, after about 20 minutes of play. It's a just standard video game. And then we would put people in the VR headset for 10 minutes on day 1 with the field of view restricted. So you're just looking at the middle and the periphery is not there. And that tends to be a lot of action in the periphery. It tends to make you sick. So we restricted it. And then day 2, 10 minutes. Day 3, 10 minutes with all over view restriction. And then after day 3, we could remove the field of view restriction and the people could play like normal with no problem. So it was like this 3-day routine. So that was good. And then we had another study where we said, we worried that maybe it only worked on this video game. So then we had another video game. So we showed that the training worked on a different video game that had a different interaction form. So that's one thing.
So what hardware you're using, sir? What hardware for this VR device?
We have a lot of headsets. I have a colleague who's more the hardware guy, and he loves to buy headsets when he can. So there's like a shelf of headset. But I think it's MetaQuest Pro, and then there's a fancy one called a Varjo, VARJO, and it's like $6,000. It's really expensive, but it's got beautiful eye tracking data.
Okay.
And the Meta won't let you see their eye tracking data. So they're doing the eye tracking, but they don't.
Eye tracking also you are doing some research.
Yeah. So in the Varjo, we're like, where are the eyes? Because we think if you're about to get sick, some people will stiffen their neck to compensate. And so, the accelerometers in the headset, you can measure how much they're moving, and you can look at the eyes. And I think it would be interesting to look at eye patterns. There might be eye patterns we can detect to show that you're getting sick. So I've got one machine learning student who's trying to look at that data.
Okay.
So it might be that sort of thing. So do that. Then the other big area is human AI teaming. So I'm trying to think of a short story for this. This is mostly military.